That turns on.
Yeah, the legal team was
Fantastic.
because they're like,
Replace it.
wow,
I must use this one.
there's another
They would.
group at F5 that's like.
We have a big school. I have to send a lot to get people in.
Technically
Do
covered.
you want to send out the email until then, if you can?
So you guys have to assure us that you
It's
want
the same.
everybody in
And
there.
then if you from the, just don't send the host.
Why don't you go back?
Okay.
We're all.
All right, other than that, you guys are all set. You just gotta plug in the laptop and you're good to go.
Okay, excellent. Thank
All
you.
right. You're welcome.
Yeah, I know.
Hey.
I know how everybody gets with the residuals. It's a reasonable concern. Flip side, because we're Google, people talk about all kinds of stuff with us. And every time somebody says, oh, wait, I had that conversation.
Thank you, Matt.
Yeah, no problem, man.
Took away
Take it easy.
from these days. A lot of obvious stuff gets patented. Yeah. The lawsuits fly. Oh, yeah. It's a necessary thing. The bigger you get, the more important.
You get
That is not from a standpoint of forcing people to open that door for you, but just from the, dealing with the litigious nature.
Well, the use case when you have.
Like I said, maybe that we just
Now you kind of.
not sign it. That would suck, but just make the business decision.
Yeah, no, that's just it. It boils down to a business.
The pieces are there.
And
Don just
decide
gotta
what's
write that.
Okay, so we talk about that flow,
You know, as a company.
and how some of that can be
It was
done.
least risky.
Several sides compared to
I mean, I think what it comes down to in my mind is,
the,
do we have a
As
history?
an alternative to NAPPS, or is
Of
it
that,
variant to
right.
NAPPS?
part of now.
Yeah.
Part of that, so
You know, if that's something you have legitimate reason to
TA
be
as a
concerned
service.
about, then.
No, I think that.
We've had,
Instead of DA trying to have.
Usually our legal team gets hung up on
Multiple AS and access to
indemnity.
need to be.
We had
The idea was that if TA goes to the
situations where we
AS, its own AS.
We carry it.
Someone-
Primary token, and they say, I need the secondary token.
someone,
for one.
uh,
Then the.
we had a
primary
partner
AS goes to the.
who was a small guy.
Have one AS.
Fact check.
And say, give me the access token for.
somebody got mad at them or
And then
patent
just,
and
if
then
the
came
cost
after
group, nobody needs
us.
to know. And then
Saying,
at
oh,
that
via
time,
them, you're.
have one AS
Yeah.
is actually just consumed it and.
I think I've got that buried.
Yeah, so he was saying, how come we didn't talk
It
about it?
happens.
I'm pretty sure we discussed it, I don't know whether we captured it or not.
Yeah, there's different ways you can,
But I think
Well,
the
there's
reason
never
why this was
explained
kind of good is
answers for
because
that,
then
it's always a question.
the issue
TA can be done.
Yeah.
He can be very done,
Then we had a
and
lawsuit.
then the second call
Where-
for validation doesn't need to happen because, you know, and then
We
the
licensed
change
some technology
on the AS1 and
and put it in
AS2 is
the
very
ID.
limited. And all you have to do is issue a token,
And then it was
then a primary AS hospital.
But the burden on the SaaS
some
AS is the same, right? I've got to
disagreement in
support
how
the
we ended
assertion.
up marketing it.
Because I'm gonna,
Yes.
you know, whether that request comes
And
from
making it
TA
available, how
or
we made it
from
available.
Yes.
The server and everything.
And there is more effort on the
Only on
AS,
this,
which I think is.
you're not allowed to say it as this.
Because I think if you do it right, you will have 3 or 4.
It was all about
AS
identity, or
primaries,
not identity, it was all about
and you have a lot of
location.
TAs. And there's a lot of
They had
TAs,
location
I
of
would
the user.
expect the Indian when there's now
We said,
respecting
you
all
know,
the
they were
layers.
saying, yeah, we told you that
So,
at least in
you
there,
can only use
Yes.
location.
And then you
So
pick
traffic
out-
management, cover for identity.
until the OS wake up.
yeah, and
We're like, it's all the.
And it's part of iOS 9.
license it, I gotta choose, but
then you move on and find something.
that ended up into the big, settled out of court, but there was.
I don't know if Don is coming or not.
I thought I paid for him.
Maybe he, it's on.
Don's in Mexico.
Yes. exactly.
No, but if you pay for it.
Oh, okay. You got me. All right, let's call him.
Yeah. He's gonna send his,
Skype in from the beach.
Yeah.
I was interviewing someone who applied to Google, and they're like, yeah, I heard about Google through my girlfriend's father. I'm like, oh, what's his name? Don Tebow. And I had my phone in my hand, and I was currently with my parents. I was like, did you meet him? Read it out. He ended up on our teams.
And then you tell them about
He did
Google's
join
privacy
Google.
policy.
Yeah. Going to a voice messaging system. Hopefully that means in transit or maybe on airplane.
Okay. Recycle this. Food salads. I do a little bit, mostly on the back of stuff that I have to have. How about the back of
Now do I really can't, that's just, I want to see if you understood what Paul was talking about as far as space already.
So are either of us specifically signed up like for this tender?
But how are you gonna do this live?
Okay.
Yeah, no, I'm waiting for anyone to join it. I sent email to.
And this points to.
Yeah.
What about this live?
What is the best way? Are you using a primary laptop for presentations? Or do you have to make some stuff? Because I believe you can just join and present to it without audio on your mic. So different than you just join. Let me test that.
How about we like
Hang out, Andrew. Andrew wanted to join.
I thought you sent it out.
Do the event director.
Oh, I don't know that Andrew signed up.
You just need to speak.
Because he's not in town right now, he doesn't get back on this.
I can
He may pop in.
If we use this,
Hey, how are you? You see?
We should have carpooled this morning, Andy.
I said, yes, I'm going to.
Gotta figure out if we could have carpooled in. How do you know that I'm, because I'm not yet in. Oh, I thought you were already moved Saturday. I had to delay it because we had this war.
Do the job. You can do it every time.
Oh, really? We're gonna do a DIY. That is your time stuff.
Means sanding the whole floor and restaining it.
Yeah, and then doing it.
It says we have 2 viewers. But I can't see, I'm trying to figure out how to enable them to be able to talk. Control, cameraman, disabled. Why is that disabled?
Yes, I had to rescan. We didn't have enough time to let the thing appear, so we did the second part one. A couple of the rooms.
Yeah, the whole house is a big, that's a big job.
Everything but the kitchen and bathroom.
I'll get to this one. I'm just.
Never again.
Okay.
3 viewers. If you, maybe it's possible, but I can't figure out how to let people talk through it. Not necessarily the audio of this is that great. So people can watch us, but they won't be able to talk out. They would have to IM somebody here. So if you want to try
we have audio.
WebEx.
We have audio call.
We have an audio call?
Yeah.
So they could talk through that?
Yeah.
Okay.
And it's connected. And
Okay.
you can send an email out to all the
It's the audio? Sweet. So they got video from here and audio from there.
And then we have WebEx here.
Cool. All right. We'll give them
And then
multiple
we have
choices.
2 people who may join.
Yes. All right.
Yeah.
Multiple choice.
She's going to send the audio information out so that if anybody wants to send out back
Right.
to their team members, they can do so.
Yep.
And then all the speakers will join the WebEx.
Right. And when we protect take that, stick it there, and put it to the
Yeah.
screen.
Yeah.
How do you want to handle the IP?
With
Yes.
Mike Jones to say, this is the rules if you don't want to talk.
Yeah, that's Don's goal
Value proposition.
value prop. Yeah.
We could, if I could find that email that John sent.
Yes, we can just forget it. I have that.
Do you have identity?
You want we send it to you? I remember saving it, thinking I'm gonna need it on that day. Okay, thank you.
You actually found this?
Yeah.
Oh, okay.
Yeah. So I think she's the first one. Or you wanna get on the WebEx?
Only thing is that
I see that.
Don says he's stuck in the airport.
Okay. And you can hang out with How was your dinner, Brian?
Good. It was good. It was a little more vegan than I had anticipated.
You go to a vegan restaurant not knowing what to expect.
I had suggested Indian, I think, 2 weeks ago, more. Indian place that would have something for both of us, but
Anticipated, you think you weren't that trouble finding it?
I think we just found a place that he likes, and that's where we went. But I survived. Thanks, John. He's drinking from the $5 bed 2 weeks ago. But, yeah.
You get free videos, I assume.
Because the most important part that you possibly get is $8 membership.
I told Don, if you could, he could try to dial in and give an intro, but it doesn't seem to be on IM, so I think he has bad connectivity, so I think we should just go ahead and start. John is watching us through that. Hi, John, and he's gonna try the other audio and.
Hello, John.
You can't talk, which is awesome.
Whoever set this up.
This is great.
Perfect.
Yeah, somehow he's probably doubling his salary to work for Netflix, but everyone wants to know if he'll get $8 a month for free.
I imagine he gets videos that we don't see as well.
I asked him what kind of perks there were. Not too many. You guys have to make their own copies. Oh, did you sign it?
Canceling my interview request.
So you burn his hand trying to figure out.
So we'll give it a couple of more minutes and then we'll get started. If there's still people hanging out in the lobby.
Hey, Paul, John just complained that you can see.
I don't like to see him either.
Is that too weird?
That will slide over. They started off as applying for a TN visa. Spent a lot of time there. What do you get? So I get tomorrow. And you just you need both sides. Sit there for an hour and a half. Just. Well, it expires. So I'm in there with a guy who actually caught me. So he's, and I'm just smart enough to just be quiet and sit.
Hey, Lucas.
Just to try to stress you out. So that'll just.
Not quite started yet, Lucas.
I should.
You can come back on PG. You get on the inbox. Okay.
Hello, sir.
Hey, guys.
This is a lunch we had at CIS. You're on.
Yeah, I guess it was actually. Companies try to get us together, and put the items work.
Some companies are better at keeping it small. That's a whole, that's why.
Hey, how are you? Shweta, you can start now, right?
Yeah.
You have everything? Okay.
Yeah.
Right, thanks everyone for coming. My name is Ashish Jain. I'm a product manager with VMware. Don, who is the chairman for OpenID Foundation, was supposed to be here, and I think he's stuck in traffic, or I guess airport, so I'll do the introductions part. I think the first thing, which is the most important thing, is that the IPR policy, read through it. But I think if you haven't signed the OpenID or OIDF IPR contribution agreement, then I guess don't speak. You can still listen in, but you cannot contribute. And
Well, you can, but it's just understood that if you do so, it's under the IPR policy.
okay, so just be kind of aware of that before you say anything. I think in terms of logistics, I think there are three main important things. The coffee outside. If we run out of coffee there, we also have a kitchen, so we have coffee flowing throughout the day. The second important thing is the restrooms, which is if you go out and take a left, that's where the restrooms are. And the third important thing is the Wi-Fi. It's VM guest. There is no password. It's a little bit flaky, so if you can't connect, just pay attention to the discussions, I guess.
You need to use the mic so that those on the phone can hear you.
Thank you.
You might want to remind them of the IPR.
So guys, on the phone or whoever is connecting remote, the other important point on coffee and restrooms may not be relevant.
Or Wi-Fi.
Yeah, or Wi-Fi. But I think from an IPR perspective, if you are listening and coming to contribute, please sign up the OIDF IPR policy. Otherwise, whatever you say will be complied by that policy. And in addition to that, we also have WebEx. The information about WebEx was sent on the mailing list. We also have an audio dialing information. So if you have people in your office who want to join in or listen to the presentation, they can do so. We also have Google Hangout video playing, so people can actually even watch us. So if anybody has a startup idea to combine WebEx audio and Google Hangout into one, I think we will take it. But for now, we're going to do all three. So the agenda for today, I think I listed over here. We're going to start with the NAPPS overview, just to kind of give you an idea of where we are. And I think this meeting got started at CIS, where we said, a few of us should do a whiteboard session, and then let's make it open. And then as of last night, we had like 70 registrations. So they're definitely interested in this topic. And when we started talking about it, we realized there's a lot of prior work which has happened. So in addition to the NAPPS spec, between VMware, AirWatch, and Ping, we have done one implementation. Centrify has mobile SDK, which has been out for a while. Google has done a bunch of work, and they continue to do so in the Android L. And then Samsung Knox team, if they are here, they also have done a bunch of work. So we thought before we figured out the next steps and the actual open items, it would be good if we're all on the same page in terms of NAPPS overview, Centrify, Samsung, and Google. So we will do all that. And depending upon how much time we have left, we will either have the discussions this afternoon, or we will continue them on the mailing list, or we may need a follow-up meeting to get to. One more thing before I forget, so in order to kind of plan this, so Emily and Shweta, you can stand up real quick. They kind of did all the planning, so if if the lunch doesn't show up. Exactly. So I think that's about it. I think with that note, I'm going to give it to Paul. If you have joined the right call or not.
I have.
Okay.
Could somebody verify they can see it?
Yeah.
Okay. The camera makes you look bad.
Morning, I'm Paul Madsen from Ping. So I'll do a rehash of a deck we did for the OIDF Foundation update.
Can I borrow my time? Should we do quick introductions too?
Do you want to do introductions quickly around the room?
I know there are a lot of people, so it may be a bad idea, but I think it will still be helpful if
We
just
only have
quickly-
till 1.
Just name and company?
Sure.
Okay, so you start.
Brian Campbell, Ping Identity. Nibby Agarwal. Thomas Manning, one login. Troy Simon, one login.
Emily, VMware.
Kabir Bardet, Airwatch. George Apogee.
David McNeely, Centrify.
Ravi Natarajan, Young Planet.
Hey, I'm Andy Yoler with F5 Networks. Andy Small at Google.
Maritime, Google. Tom Imperial, Privada. DJ Boomer, Privada. Raj Privada. Thomas Puma, VMware.
Vikas Patani, Mobile.
Josh Sorota, Mobile Iron. Atul Mahajan, Will, NetIQ. Lloyd Birch, NetIQ.
Gary Thomas, Sonograph.
Sabrina Taylor, Canada.
Brian Khan, Kimbay. Jeffrey Hitchcock from VMware. Blake Barrett from VMware.
Peter Gillian, VMware.
Saturn from VMware. Mike East from Google. William Dennis from Google.
Martin Smith, Google. Google, good technology.
Eugene Weiner. Isaac Correa, Stanford. Mike Meehan, Self-Made Self.
Roman Guinness, author.
Tom Gannon, Mobile Iron. Vijay Pawar, Mobile Iron.
Martin Chen McKesson.
I can now from Samsung. Simon John from Samsung.
Mortez Ansari, Cisco.
Adam Dawes, Google.
Rajiv with Indigo.
Did we miss anybody? Was it?
On the line.
Yeah, anybody on the line care to introduce themselves? John Bradley from King is there. I'm not sure who else.
Hey, this is Lucas Chen from Airwatch.
Okay, great, welcome. So NAPPS, well, why we are here today, stands for Native Applications. It's a work group for the Open ID Foundation. And the value proposition is to enable a so-called single sign-on experience across native apps. So OAuth and Connect come along, and they're great. They enable an authentication model for native apps calling REST APIs. But out of the box, both of them presume that each app is individually authorized, authenticated, issues tokens. So the NAPPS motivation is to enable an experience whereby a user logs into one native app, and that session, if you will, is able to be transferred or at least usable with other native apps. So here's an example of, just for background, a native app, a SaaS native app. The best practice these days seems to be that each SaaS built their own native app, built their own authorization server, hosts that, and the native app expects to get OAuth tokens from that AS. So that's just plain OAuth. Maybe now Connect, but the pattern is the same. And then in order to authenticate the user into that SaaS AS, arguable best practice is to do some sort of federated browser SSO back to the enterprise. So it could be SAML, it could be Connect, it could be OpenID. They're really disconnected from each other, they're orthogonal. So what does that look like? A horrible build here. So this represents the SSO operation, SAML, what have you. And completely separate from that is the issuance of an OAuth token, via the browser typically to the native app, store that away, and then use it on API calls up. So that was misleading because it suggested everything started at the enterprise and probably would have started at the native app, but the logic stays the same. So that's great. SAS RS validates that token, says, yeah, I issued it, is able to look up the identity of the enterprise employee that the token represents, do an authorization check, we're all good. The issue, of course, is that you repeat that for the next SAS app that employee has on the device. And refresh tokens may make that manageable for the user, but the default assumption here or implication here is that the employee is being sent back to their IDP, on some relatively frequent schedule, and a frequency that probably is not one conducive to happy employees and productive employees. So, more logins, right? Mobile logins, almost by definition, small screens, etc. As I said, refresh tokens can make that bearable, but for some that's going to be unacceptable. Kind of from the other point of view, from the SaaS point of view, some small SaaS, that model presumes each SaaS is going to have their own authorization server. And for those who sell authorization servers, that's great, but it's not maybe practical for some startup SaaS. And from the enterprise point of view, the enterprise is mostly removed from how their employees are using those SaaS apps, because they're really only involved at that initial single sign-on step. And after that, it's kind of a direct relationship between the employee on their device and the SaaS. And some enterprises want greater visibility into when those apps are used and have greater control over turning that off critically. So at a high level, this is how NAPPS changes that model. So here's a token agent. So NAPPS defines this conceptual thing called a token agent. Here it's represented as an app itself, but it's really just a role. It's a piece of software. We'll talk about different entities that can play that role. But NAPPS starts off, or the NAPPS flow starts off with the token agent, like any other app, doing an OAuth or connect flow to get its own tokens, just like any other app, right? We know how that looks. And just like for any other app, the user could authenticate into that AS through a federated SSO. Once again, that's distinct from what's going to happen going forward. So step 0 is, the employee mediating, or the user, consumer, whatever, mediating the issuance of some tokens to the token agent. And what NAPPS says is that the token agent is then able to use those tokens to make appropriate calls back to the authorization services infrastructure to get additional tokens to then hand over to the business apps that we're trying to enable. So step 1 represents the token agent saying, I have a token, probably going to be a refresh token in the model, that represents this user, handing it back to the authorization server and saying, for this user, I want an access token for a different app, not myself, a different business app on the device. And then through magic, OS-specific magic, hopefully, kludgy custom URL scheme magic at worst case, the token agent hands that access token or something else with the specifics to be determined over to the app. And the app now has a token. It didn't directly get the user involved in the typical default OAuth or connect flow, but it has a token. And now it can use that token as if it obtained it directly against its RS. So once the app has a token, it's plain Jane OAuth or connect. Just uses it on its API calls as OAuth stipulates. How the RS validates that token, like in normal OAuth, is going to depend on the token type and the trust model, et cetera, between the RS and the AS. So, it could be just a reference style token that needs to be looked up. We will support that. It could be a JOT type token with self-contained attributes and signatures, et cetera. We'll support that as well. So the value proposition of NAPPS kicks in for the second app. If you only had one business app, you have gain in. It's that the second app can be enabled the same way. We don't have to kick off a new explicit login for the user, because we still have some refresh token that is sufficiently long-lived for the token agent to go get another access token, a new one, specifically targeted at that second app. And then as before, magic, send it up, those apps just work, right? They didn't explicitly take the user to a login, but they have tokens that represent the user, that are valid, haven't expired, and can be trusted, quote unquote, by those RSs. That make sense? Any questions?
Yeah, I have a quick question. So with respect to that sort of data flow that you've got there, it seems like you obviously have to have a native app that's aware of the token. Otherwise, I mean, the natural model that seems to me is you would create some sort of proxy which the app wouldn't know about. It would basically intercept that request at the OS level and basically then push back a token for you, which you can validate against any of those backend RS. So that seems to be, you have to basically rewrite your app. So if, let's say you've got an existing page, you can't sign that particular model.
So I don't think you necessarily have to rewrite your app. If you're, a typical OAuth-enabled app is going to pop that browser window, go to the AS endpoint. You could intercept that, right?
So you're assuming then that the app has to use a browser or an old model to get it?
Well, this, by definition, this is an OAuth-enabled app, right? Because we're trying to get it an OAuth token. So yeah, there is a presumption that those apps are OAuth-enabled, and additionally, they've got to be NAPPS aware, likely. And likely, they probably need to work both in a world where there's an agent present and not. Because these app developers probably don't want to write their apps twice.
So why not use a proxy as opposed to a client-side proxy that behaves, looks to the applications as if it's, I mean, it looks like the token agent, it almost a proxy, but not quite.
Well, so what I didn't show is, so this is kind of in the parlance, an IDP-initiated flow. Apps don't start it, but if the user clicks on the app first, then the app can invoke the token agent and get a token. So I think that's the proxy model you're thinking of.
Well, I mean, some apps, the way the workflow is that they don't necessarily immediately start up sequence. So they wait for the user to initiate a login of some sort. So I'm thinking, particularly, let's say, the user will require to enter ID before they access the application because they're sort of many users on a single platform.
John?
Hello?
John, we can hear you if you have something to say.
Oh, sorry. Sorry, another call that was coming in.
Darn.
Did you want me to say something?
No, not at all. I think we're good till about 1.
Is it possible to repeat the questions?
So paraphrasing, the question is, why would you not go with a proxy model where the apps need not be directly informed of the presence of a token agent? Thoughts? John?
I just thought him ask me.
A network-based proxy?
No, I think just a device-resident proxy, but one where the apps just ask for a token as they normally would, without being NAPPS enabled. What do we gain?
Well,
Yeah, an interceptor model.
The application then has to independently go through all of the authentication steps independently, and
that's what we have now, so it's not actually an incremental improvement.
No, I think that the proposal is that the agent gets its tokens, and then the apps ask for a token through an authorization request, and the agent intercepts that and returns, does its magic, and then returns the access token.
Well, that would be nice if we actually had the hooks in the operating system to intercept those calls.
Yeah, you'd need to intercept all kinds of URLs to all kinds of.
Yeah,
You know,
I would say, I don't know many people that would approve of that security model in the first place. Would it?
You can have, like with most browsers, you set up, within most companies, they have a proxy that you go to, you don't go directly to the internet.
So you're talking
Yeah,
about
I don't know
outside the device.
and giving the token agent the ability to intercept all HTTP calls might raise a few eyebrows, because that's pretty much what you need to do.
I don't imagine Android providing that functionality to anyone, ever.
And you could do it as a network-based proxy. The problem you run into is getting, IP through having tokens stored in something that's not the device.
That's what it works in the MDM, where you control the device and it's your device and you can provision what you want about it.
Yeah, that's a good point. In an MDM MAM world where there's a tight binding between the app and the agent, then maybe that's possible.
In any case, I think it's ridiculous that a native app developer has to pop a web browser for something that's an activity that.
Right. That's what I'm thinking. That's why it's better to have a proxy that's running there, because then you don't have to look at the browser. Effectively, you're using the browser caching facilities and all potential problems that might exist within the browser itself. You're opening up your existing process.
Well, you may be cleaning up the UI slightly, but you're creating other problems along the way. I mean, that's exactly why we're talking about the agent the way we are, and we're looking at this as a way of solving these problems. And instead of having to intercept things and dealing with all the pushing the other problems to other people that aren't necessarily going to accept those problems, we're looking at attacking this in a more fundamental way.
Well, I'm just saying that use the browser, the issue is that, for example, when you put that browser window, there could be all sorts of JavaScript.
Yeah, I don't think anyone here is advocating popping a browser.
Okay.
So again, there's nothing in the NAPPS model that mandates a browser. I showed it as a browser because there are advantages to getting the user logged in via the browser, WebSSO as an example.
Okay.
But there are other grant types in OAuth available to us that don't presume a browser, and NAPPS can take advantage of those.
Just to kind
Well, Lloyd beat you.
All right, I was going to respond.
Well, I'm actually changing the subject slightly. Mine is more specific, trying to understand the scope of the group. You talked in step 5 and step 2 of magic, which is very appropriate there. And I'm trying to understand, does this group plan to define the magic of the security of how the token is passed, and not only how it's passed, but how is it passed securely? And do we plan to address defining that for iOS and Android at least?
So currently the spec is divided into two logical pieces. One that focuses on the wire, messages 1 and 4, and that flow.
1, 4, 3, 6, all of those.
Yes, right, and that's, John is editing that spec. And
Paul, John's asked that you repeat the questions to the extent that you can.
the question was the scope of NAPPS, and is NAPPS aiming at defining the security characteristics of messages 2 and 5 here, and the inverse. So John Bradley is editing the OpenID Connect profile to enable messages 1 and 4 and associated, others related. Thomas DeBetting is editor of the logical other half of NAPPS, that which focuses on potentially OS specific, but at least allowing for a standardized custom URL scheme. So I think we're at the stage in the spec where the first part is relatively well understood. We've got Connect, we've got JOC, we've got assertion profiles. We think we have a reasonable grasp on how to get tokens to the agent. And now we're confronting the reality of how do we securely distribute. Okay.
So I take that as a yes, it is a scope within this group to define the secure transmission. And the reason I bring this up is if we define everything on there, but 2 and 5, the apps, there will be no standard by which pieces will interoperate because there's not a secure method of transferring the token. And so without that final component, it'll always be a puzzle with pieces missing.
So, if I understood, you're worried that we don't have sufficiently broad scope to ensure interoperability?
Include 2 and 5 on at least the 2 major mobile platforms that are there. And they may be very different. I mean, how you do iOS and how you do Android might have different components of how they're done.
Absolutely.
But the specifications should say, on iOS, this is how you do it. On Android, this is how you do it. And that I'm encouraging strongly that that be within the scope and not, well, we couldn't quite figure that out, so we're just going to do the first part, because then we don't have a secure solution.
So definitely we want to deal with 2 and 5. Okay. And my understanding of the current situation is we're going to define a lowest common denominator of custom URL schemes and highlight through security guidelines the issues with that, and also point to the two key mobile OS, the specific recommendations on how to do 2 and 5.
Okay.
Is that not strong enough?
As long as the spec for iOS doesn't say you should use the URL scheme to do this, and we understand there's some security issues, and we'll let you resolve that, because everybody will resolve it differently.
No. So I think the idea is you say both iOS and Android give you OS-specific mechanisms to do 2 and 5. And these are the ones how you should avail yourselves of them. If you can't do that, custom URL scheme.
Just to follow on to that, I think if you look at the spec, we also talk about how new operating systems should handle this as well.
Correct. I was being just specific.
No,
if you don't just get that much, people aren't going to use it because it won't interoperate.
The important ones, and this is what you should do if you're actually writing a new operating system.
Completely agree.
So there's, I think, Thomas, that's a recommendation for you.
Yeah.
That the binding spec, or what we call the OS binding spec, should give high-level guidance on how to do this in a as yet uncreated OS.
To be more specific about that, a lot of what I think the room is thinking about are enterprise use cases, but we're starting to see the world of TVs and set-top boxes and all of these things. Google has a lot of applications that want to be able to use this model on those other platforms. So it would be useful to be able to tell a TV manufacturer, you should support this standard to help facilitate access to various applications on your platform.
Okay, good point.
In one incarnation, browser could be the token agent, and that should not be ruled out because that's kind of the lowest common denominator on many platforms like TV, where essentially JavaScript in the browser is acting as a token agent, and you get a custom URL redirect back from the browser.
I don't think there's anything in the spec that would preclude that.
So I just want to call out, I think one of the things we were thinking of basically making that the lowest common denominator for at least any operating system if you did not have a token agent. Okay. And that might be worth calling out.
Finally, Brian's turn.
Other sort of benefits of this, potentially if someone has multiple devices, you could recognize that, they logged in on this one, and then
Sure. It implies a different binding for the token transfer. We played around with that. Brian, you had one?
It's not really relevant anymore.
Mission accomplished. So I guess I've got a few minutes left. I guess the relevant to talk about is just the different potential different trust models and relationships between the AS and the RSs and how many ASs there are. So in the simplest world, all these apps are logically within the same policy domain, and there's a single AS. So we have enterprise customers, right, that are building their own native apps, and they want to enable single sign-on across all those apps. So that's a relatively straightforward trust model. The RSs are just going to continue to trust the sole AS that they've been hardwired to trust. The only thing that changes is how those apps get those tokens. So, in this world, basically the existing OAuth or Connect trust model works just fine. However, there's apps out there that have been built against or built on the assumption that they get tokens from their own AS. So think large SaaS, right? Salesforce, et cetera, have built their apps and a trust model that presumes that their AS issues tokens that their apps use on API calls and not some arbitrary AS in the cloud or associated with an enterprise. So this implies a different trust model if we want to support and not impose on these types of apps and resource servers a different trust model. And the spec supports that by a model, we'll get into it in details, but instead of the TA obtaining an access token directly from its home AS, it obtains a JOT or an ID token that it can then exchange against an AS associated with those different RSs. So there's more steps, and there's more of a burden on the AS, and apparently you guys were talking about a different model for enabling that. But the end result is that the apps get a token from their own quote-unquote AS. So we maintain the trust model that those apps currently expect.
What we talked about wasn't fundamentally different.
Just a different flow, right? Yeah.
But same trust and tokens.
Just shifts the complexities around.
Can you get that automatically with the box? Get that automatically. That would just not out the box. It goes to whatever it wants to.
I don't think proxy changes this, right? Because ultimately it's the RS is going to get a token. Does it validate that token in the way it currently does? That's what we want to make possible. Sure, but the spec still needs to support protocol flows that that proxy may choose to use. Kind of related, not all enterprises will host their own NAPPS-enabled AS. So there'll be, cloud ASs. How does that work? Probably doesn't change the NAPPS flow. Might change how the user is authenticated into that AS. So here's the stack. So we're building on OAuth. NAPPS itself is a profile of Connect, which is a profile of OAuth and JOT, etc. And all the other pieces. Some assertion flow in there. And that
as a TBD.
Device API, I guess, is, maybe that should have a question mark, but I guess that's a conjectured standardized API that, that we hinted at when we talked about the OS specific bindings. And we conceive of normalizing that. I know the MAM and MDM world have contemplated normalizing that sort of SDK. And one logical piece of that would be token issuance and request response type models. I think that's, well, we talked about the current model, talked a little bit about federation, talked about different ways that the relationship between the ASs, etc. I think it makes sense for me to quit there. Any questions before who's next?
I think it's Emily and Kabir, which were next.
Well, I have a quick question.
Sure.
So I are you, in this model, are you suggesting that the different RSs are using different ASs, so is the same token agent being able to talk to different ASs, or the different ASs have a mutual trust between them, so it can trust the...
So in this model, the ASs trust each other.
Okay.
And the RS trusts the middle AS. And this is, the advantage of this model is that the RSs don't change. They continue to get tokens from an AS they currently trust.
Okay.
The burden falls between the two ASs and the TA to make that happen through
So the
token flows.
the TA has to be aware that the token is requested for an RS that doesn't belong, or belongs to a particular AS set, and then be able to exchange.
The TA may not bear the burden of knowing. So the TA is just going to ask the AS and say, I need a token for Salesforce.
Okay.
The logic of, oh, gee, Salesforce has their own AS, can lie with the first AS.
With the first AS, so there has to be mutual trust between them, and they have to, so it's just a token, if it's an opaque token, it's okay, but you're also passing identity attributes in that, and they have to be relevant to the other side.
Correct. That's, I mean, Federation already leverages a trust model between an IDP and an SP, whether it's SAML or Connect, right? We're going to leverage, we would leverage that trust and potentially the attribute sharing mechanisms that are already in place.
I mean, step 2 and 3 could be on the trust line there as well. That's not good. You could get a token through the AS and proxy through the.
Yeah, what is meant to apply here is that TA gets a token step 1, and the AS is smart enough to know, oh, well, you need this type of token. And that type of token indicates to the TA, oh, I don't just directly hand it over to the app, I got one more step to do.
Right, but some of those flows involve user interaction also. So if you look at, the SAML federation flow would, if you didn't have the two identities related, it would require the user to go to the other side, authenticate, and then you have a. What I'm saying is there's no user interaction would be involved here, but the ASS would be able to mutually exchange.
So there may not be user interaction. There's always the possibility if consent is necessary or relevant that we can grab that. Even if we don't need it for the issuance of the token, we may need it for consent. And we've thought about that to some extent.
Consent would be, I guess, relevant but not more relevant part. I was trying to think of establishing the link and the identity on the two sides, the federation piece, right? So if you were to just pass an email address as your identifier from AS1, how would I know that that relates to identity B on the other AS? How would the other AS know that these two identities?
So how do you tie those two identities together? Yeah. So you either NAPPS doesn't solve that, doesn't change that issue. You either pass all the identity attributes in the assertion, ultimately in the access token that makes it to the RS, or you have previously bound those identities together.
The linkage that you've done out of them.
Yeah.
So I wanted to just go back to two things you said at the beginning about the goal. You made the joke that, hey, AS vendors, we like selling ASs to things, but that might be too high a barrier for some. But if it's enterprise SaaS vendor, please tell me otherwise, they're going to have to support it still a mix. Not all of their enterprise customers overnight are going to turn this on for the foreseeable future. They're going to have to run an AS, and this is just honestly a relatively small thing. They support satellite support it when I can actually support passwords. This is doing other things, but I don't see it significant change.
So a small SaaS, even now, without NAPPS, could outsource all their AS to a cloud IDS, right?
So they have an AS, either they run it themselves or they can. Yeah. The other one I heard you talking about is, hey, that IT admins, the control aspect. Oh, there's the sign-in part, and once that's done, there is some loss of control, and this will help with that. That doesn't actually sound true to me, and I don't think it's necessary. Again, that's how SaaS works today. You do SSO, you hand off control, and you have background ways to say, auditing, control. Here you said the same thing. At the end of the day, a SaaS provider is going to get the exact same, they're going to issue themselves the exact same token they've always done as soon as that initial authentication process is done. I don't think this inherently provides any additional.
Well, except that the SaaS AS, in step 3 is going to issue the same token it normally does. But this model has the TA, which is a proxy for the enterprise on the device and actively involved in the issuance of that token.
But once it's issued.
But the difference, I think,
but it gets a long-lived refresh token, and it uses that in order to get new tokens to use on call number 2. So the enterprise is involved more.
So you're suggesting that, again, you know, the Salesforce is the world, they already wait for their own app to, on their, you know, business logic to go back and get additional tokens. And that already exists today. Again, orthogonally, how authentication happens. Are you suggesting SaaS vendors need to change that?
I'm suggesting that enterprises would prefer
Sure.
a model where they're more involved in the issuance of tokens.
I doubt most price SaaS vendors, being a big one, will even consider that.
Okay.
So I would make sure that's not a requirement in the design.
I don't think it changes, you know, what you do. It just it puts the enterprise into the flow before you get your tokens.
And as long as the enterprise customer, once they get this one token, from then on, it's what they do. There's the control up front, the same control they have today with Salesforce Identity Connect, but as soon as Salesforce is, quote unquote, issue their own refresh token to their own app,
as long as you,
same as today.
Right, as long as you continue to give to them the ability to set the lifetimes appropriately with those refresh tokens.
Which is, again, it's their refresh token, they're already doing that.
Well, but they're specifying that through your admin streams, right? Your AS.
Who's your in that point? Enterprise or Salesforce?
Your Google's enterprise customers are able to specify
but how long
the refresh token lasts.
And that's orthogonal to whether it's Salesforce Identity Connect
Sure.
password or this. I don't think this changes that part of the equation.
As written, though, it does, because as written now, there's no refresh token, there's no secondary refresh token issue, which would be the SaaS side. And
I expect they will do that because that's the only way to not massively change how their systems work today.
It would.
So your enterprise customers, based on what we hear, won't want that additional variable to worry about. Okay? Because when their employees leave, that long-lived refresh token,
which they already have a way behind the scenes to
if scam or otherwise,
Salesforce to
yeah. So that's the alternative. The enterprise, when they fire the guy, they either actively deprovision,
right,
or they just turn off the tap.
Right. And I'm saying
both are valid.
You can suggest and ask enterprise SaaS vendors. I think you're kidding yourselves to think that more than the time you would. It's too large a change for them.
Okay, so bottom line, you're suggesting that NAPPS should not preclude a refresh token being issued because large SaaS.
You can't even stop them from doing it.
Well, we can say, you know, NAPPS compliance, right? That whatever that means. that's going to mean a lot. It'll be in RFPs, right?
In this case, the action actually rolls through the TA, so it could. I probably wouldn't know to pass it, but
that's a valid point. Yeah.
So we hadn't considered the second AS needing to issue a refresh token because the assertion that's used in the assertion flow is essentially the refresh.
And then you need to share your desktop. Oh. That's a good idea.
So today we're going to share about our findings or whatever the experience share with you about from the implementer's point of view instead of from the overview, the high level like Paul shared with you. Why are we here? Why are we implementing NAPPS? So basically, we're trying to enhance user experience of our joint customers between VMware Workspace and AirWatch. So we want to consolidate all the app catalogs to give the user a single point of catalog and launcher. So they will be able to launch not just their mobile apps, their SaaS apps, and their hosted apps, and etc. We also want to extend the single sign-on experience to the end user, so they don't have to do constantly single sign-on. Do the sign-on to their mobile apps separately, or to their SaaS apps and to their hosted apps. We also want to leverage the any open standards instead of doing our proprietary way. So that's why we actually look into the working very closely with the working group, and we looking at the spec and try to implement that. And we mainly going to look into these three main use cases, and we're trying to identify what are the gaps that we see from the implementation point of view. So let's start with this one. This flow, Paul already explained. This is the very basic mobile SSO flow. And the gaps, I'm not trying to go over this one again. The gaps that I see, which is kind of there, which is preventing us from truly doing the implementation, which is can interoperable with other people. One is there's a way either we use the refresh token grant type, or we can create a new grant type, which we can maybe adding more parameters, such like the AZP parameter, or having more leverage. It just may be more clean way of doing the profile. The other one, something we already started the discussion thread in the mailing list, which is the native app identification. We actually, currently the spec is overloading the scope parameter. The scope actually will contain the ID to identify the calling native app, as well as what kind of token scope, the resource server that you are requesting, which is, I think, gave a greater burden into the authorization server to actually, first of all, they need to know, oh, by the way, this is the NAPPS flow, not the basic refresh token flow. And then have to filter through the scope, do the processing, say, oh, which one is the requesting native app, and what are the resource server group. So it's really, really too complex. So I think the direction that we're going, which is using a separate parameter, whether it is an AZP or a calling client ID or bundle ID or package name, I don't care. But we need to have something to be critically identify what the calling native app is. And then, of course, then it comes down to what to be put into the AZP parameter, and so that the TA can properly validate that, yes, indeed, this is calling from this so-called, this NAP F1, not F2. And also, the AS need to use the information to actually do proper entitlement. Do I actually authorize to issue token for this native app or not? And also, like someone of you mentioned, that we do desperately need recommendation or some kind of best practices or device APIs to do proper secure app-to-app communication. And also, we haven't really really think about the token revocation. What's the implication of that? I think that will be another something we need to tackle. Let's talk about, the previous one was really talking about the enterprise apps. Basically, they are all in the enterprise domain. Now we are moving on to the public SaaS domain, where I actually making them in a differentiated model. And the AS and TA and the device are in the enterprise model, and then you have the public apps, which is in the different domain. I'm not going to. So this approach one, which Paul already mentioned, which is the token agent going to use the ID token to obtain the secondary access token from the AS2.
So you have your container distinct from the token agent.
I didn't in this model. I actually thinking that there is a dotted line. All these are on the device. Yeah. So the gaps for this approach, or something that need to be further clarified, is so how does the AS to know that this is a time for me to issue an ID token rather instead of an access token? So some kind of resource server registration needs to be happening, and we actually current spec doesn't specify any of those. And the TA also needs a mechanism to figure out, is it a time for me to do the ID token call, or directly just sending the token over to the Kali native app? And also, the TA need to be able to know where do I send that request, the secondary ID token request for. And so there's some kind of trust maybe have to be previously set up between the TA and the secondary AS. So we think those are the areas that need to be earned out before actually.
So the second and third bullet seem linked to the first, right? Because if the AS is able to work out based on policy to return an ID token, then maybe the ID token carries sufficient information within it to enable to inform the TA with these two other questions.
Or not just the ID token, it has to be something else, because the ID token is not issued for TA, it's issued for the AS.
Appropriately profiled and
right.
extended ID token.
Right. So basically it has to be maybe some other parameters saying, here is ID token, here is the secondary AS token endpoint, here is how you do it.
And the TA is smart enough to peer inside that ID token star and go from there.
Emily is suggesting it's outside of the ID token.
Yeah. Okay, but it's a parameter return from the AS.
Right.
Yeah.
Right.
Paul, would that make that less static of the ASs then? So you have to have pre-knowledge of all the ASs. Would that make it static, or how would you add more?
Well, if there's trust, necessarily there's trust between them, I guess theoretically you could have dynamic trust established, but at least in the enterprise, those are going to be statically established.
Right. So the trust, that actually go down to the next approach. The next approach, when you're talking about trust, in this approach, actually Brian and we actually brainstormed before earlier, which is instead of put the burden into the TA to do the secondary fetch, why don't you actually having the primary AS set up the trust with all the secondary ASs, because they actually have to have the trust anyhow.
That's correct.
Right. And then that trust actually, you can even pre-register the AS to secure that token call as well.
You should be able to add one more on the fly, right? Not.
Right. So this is the second approach. And the first two bullets, I don't think is a gaps, it's a kind of plus, we think. It's simplified TS implementation, and also the the primary AS can authenticate to the secondary AS by pre-set up some kind of back channel service to service call. And we can actually probably make use of the OAuth job assertion profiles. However, we probably have to add in more information to channel through the what's the calling client, what's the targeting scope, the resource server over. So we probably need to add in more parameters. Yes?
Question. I think maybe something that I really don't know. I have no problem that primary AS can build trust with S2, but how the TA know that it should go to S2, not S3?
In the second approach,
Whatever approach that they
the TA doesn't need to know. So in this approach, the beauty of this approach is the TA doesn't need to know. TA always knows its own primary token. So there's a binding between the TA and its enterprise primary AS, and that's all. All you need to know is I receive a token request, I channel through that to my primary AS. Right. So there's the native app will send a request to the token agent. Token agent say, hey, this is a request. Who is my primary AS, which is here, because I already previously registered the setup and I got my primary refresh token. And then you channel through that AS, and then AS can do whatever it stands, doing this discovery, finding the token. If the AS cannot issue it, go fetch it. The token from the secondary AS is coming back with the token. It will send the token back through it. So the TA will be very simple. All it knows is I'm getting the request from the native client and channel through and calling my primary, only one primary AS.
So the primary AS will talk with the
Yes.
AS2 together.
That's the approach that we're thinking.
So this AS2 information
Emily?
is provided by that.
So the primary AS will keep the mapping in between the app2 and the AS2, and the AS2 has to be pre-registered with the primary AS so that runtime when TA asks for it, it knows where to route to and get
So the app has to register in the primary AS, otherwise how primary AS they go to
Right.
There's a relationship between the app and the AS.
Right.
As well,
Right.
That needs to be sort of.
Right.
That's true of whatever model.
Yeah,
Right.
either model.
Right.
The primary AS has to know.
Right.
And in one case, it contacts it directly. In the other case, it tells the TA about it.
But Emily, the authorization or the entitlement for the second AS2 still has to be left up to AS2, whether or not to issue.
Yes.
Yes. Yes.
Which it has to happen either flow.
Exactly.
AS, before can issue the token, has to make sure that this TA is allowed to ask for token for this user for this app.
Right. I could potentially have a hybrid model, we can confuse it, but you could have just what's the first token called? The token agent's token, the primary token.
Right.
That be issued by AS2 back to the TA, and then the TA starts talking with that primary token to AS2. When it returns it back, it returns all the destination
Right. Exactly.
packets and all that.
Exactly. Yes.
So there may be a privacy advantage to the other model, because in this model, Chuck, as an example, with Salesforce has made it clear that he's going to, NAPPS or whatever, he's going to get his own consent before he issues a token. So this model doesn't lend itself to AS2 popping a browser and getting consent.
Nor does the other model.
Can't his app, get a token his servers have issued, but it's not sufficient for him. He gets that all the way back to hey, he can then at that point.
Okay.
That goes back to my prior note. I think we are,
Right.
most of us try to separate authentication and authorization as much as possible. And authentication, honestly, it's not sufficient. It's
Right.
authentication.
Right.
You've got an authentication manager, but now you need consent before you actually finish an authorization.
I think John had a comment on the line.
Yeah, John? You have something to say?
Hi, Emily. So we looked at that sort of proxy model previously, where the place where we ran into the biggest problem was actually dealing with collecting consent for AS2, which was why we went back to passing the access token back to the device so that the user could be involved in the consent flow with AS2. Not to say that what you're proposing isn't possible, but what it looked like when we thought about it before was that you probably have to do something more like UMA, which is register scopes and consent dialogue from AS2 back to AS1, and that required a sort of bilateral trust, whereas in the passing the ID token to either the TA or the token agent or to the native app, then essentially AS2 only needs to trust AS1, and AS1, as say a large service provider, can have a lower bar for being able to issue, app. This Twitter app wants, this app that I might not know all that much about wants an assertion that this user is on this device and is going to use it in some sort of flow. Good enough for me. So there are pluses and minuses. The burden and integration between the two ASs is higher if you're doing it in the back channel.
Right. So maybe we can add more gaps to this one. So like you said, the last one is the other thing is the secondary ASs need to be accessible by the primary AS. So I think our Jeff from our SocialCast team actually mentioned that in some situation where if your secondary ASs are in the enterprise instead of in the public space, and then in that situation, this AS may not be able to access to the secondary AS. So that might be another
the same problem from a device.
I know of lots of networks that have that architecture where that would certainly be a problem. Or the browser can see both, but the two AS wouldn't be able to see each other.
Right. So that might be potentially another issue with this approach.
Can I ask, how do you envision asking for and getting consent in the other flow where the ID token comes back to the TA? Is it just a...
Hey, John, this is a question for you.
Or Paul.
So I think it was the similar idea that when so the TA sends the ID token in the assertion flow, and the AS is able to Eric's point, say, well, that's not sufficient, right?
Right.
And at
Think of it like multi-factor auth. I got it.
And then just force them back through an original flow.
Force a browser.
So maybe,
or its own local native UI. Doesn't have to do that.
And you just sort of fully trust the native UI to gather consent.
If it's Salesforce's app
They'll
showing its own
yeah.
UI, they'll trust themselves.
All right.
We wouldn't be at a Salesforce app by that point. We'd still be, unless
the token agent point.
But if the token agent hands it back to Salesforce, it's actually are.
Sure.
I mean, even to be honest, like a lot of the testers like Google, a SAML assertion is not sufficient to get any Google token. It is
right.
Well, in many cases it is sufficient, but we look at other signals.
Right. So those are just like what should I say? It's something like for the working group to work on. I think we should actually consider all the different scenarios and figure out what would be the best.
I think one other thing which we don't talk about is the scopes, because for the secondary RS, if there are multiple scopes that the native app needs to know, somebody needs to know before issuing the secondary token. In this flow, in the pre-registration step, you can argue that AS2 will tell all the scopes to the primary AS. Like somebody needs to know the different scopes you're allowed to have.
Right. So when we talk about scopes, it's like if you don't pass them along which scope you're going to work with, so potentially whatever the pre-registered scopes are going to be taking back. We're not really trying to say what if like one single app going to be able to talk with two different resource servers, and then both of them having different ASs. What the call is going to be look like that. So in that situation, the whatever native app trying to request a token have to identify, by the way, this time I need to get in the token for this resource server, not for the other. So we're actually having a use case where we want to leverage the single sign-on approach on a device to extending that to a web app. So in this approach, I know this is a kind of a new, still under development in the working group, but I want to share with you, and we also later on have an implementation we want to demo. In this approach, think about the IDP is a resource server. And what we actually have is having your first step, have your web apps, which is the launch URL on your device. And when they actually, the launch URL is a URL pointing to starting out from the IDP instead of directly pointing to your the web apps itself. And when the user actually tapping on the trying to open the web app, so the URL will be opened in this situation in our AirWatch secure browser, and the browser will actually detect there's no token, there's a token needed. It will send step number three. It will send the token request with the web init URL, the launcher URL, send it over to the token agent. The token agent will send the request to the using its primary token to its primary authorization server. In this situation, we're passing in the web init URI, which is the launch URL that initially the user trying to access to. The access server, of course, is going to see, you're trying to do a web init flow. What it does is it will going to generate a one-time token, which is in the end going to be able to translate it to a IDP session. It will append that to the web init URI, which is the launch URL, appending that with the one-time token. That token is being sent back to the TA. TA going to transfer that one back to the secure browser. In this case, is a launcher. It will directly the browser itself will directly just do a HTTP GET. And then in the step over there, the browser will open to the access to the IDP. The IDP will process the one-time use token. It will set the session and then generating the single sign-on token and then redirect back to the web app. So this is the flow we actually trying to leverage the NAPPS flow, since you can using the single sign token on the device to other mobile apps. Why can't you extending that to open web apps?
So that flow could be used for a consent step as well, right? If you were grabbing consent in the browser, you could send the user to grab consent in an authenticated state. To Eric's point about separation.
Right. Here we're showing some subsequent access. If it's like your token set by the IDP is still valid at the time, you can directly just go back there using that session token to launch other apps. There is still some gaps with this approach. I mean, currently what we're trying to implementing. What is the scope we're going to use? Do you using some kind of special scope, or you just saying as long as you have a web init URI, you don't have to send any scope? So this is something we need to iron out. In this approach, in the prototype we're trying to do is we actually return the web init URI plus the one-time token and in the form instead of access token. So somebody may be thinking, oh yeah, how come you don't return an access token? So this is I need to point it out. If we do need to have the app info returned, what should be included in the app info? Is it app info going to be for each of the launcher web app, or is going to be the secure browser, the launcher app itself in general?
Have we talked about app info? Maybe it's worthwhile explaining.
No, not yet.
Do you want to give an overview of what it is meant to be for?
Do you want to?
So The spec currently allows for what's called an app info endpoint, comparable to a user info endpoint in Connect. And the idea is that when the TA gets its tokens, it's going to get a refresh token and an access token, and it can use the access token to call back to this app info endpoint in order to obtain metadata about the apps that are relevant, for it to enable. That metadata might include relevant identifiers, maybe scopes, maybe icons if the TA is going to build UI. That's one way we've done it. So I guess there's a question the working group is facing is how much to put in app info as opposed to a separate endpoint at which the TA could get these sorts of parameters.
Well, yep. I don't think that it's really a separate endpoint. That
token endpoint.
The app info endpoint with just the initiation URI for the app, essentially a bookmark, works based on the theory that the TA actually has an interactive web login with the AF. But as soon as you move to a different browser container, you have to have some way of bootstrapping that login session into some sort of new session state in the new browser. So the alternative would be to actually put in, if we're using the app info endpoint as opposed to say an access token directly in the call to the bootstrap URI, you would have to put some relatively long-lived token in the form from the app info endpoint. Otherwise, the TA is going to have to keep refreshing that madly. So there's some caching issues, etc.
Right.
Probably that to use some sort of access token directly, so it can be shorter lived.
Right. So that's why in our prototype that we made, we actually didn't really truly use app info because, first of all, we don't want to, for the web apps, we don't want to append the long-lived or whatever the IDP session in the URL. That's definitely a security hole. That's the whole reason we actually did append just a one-time use token. And that one-time use token is being passing through to the in the URL to the TA. TA is going to pass to the launcher, which is our secure browser, and then the browser is going to directly using that launch URL to get in the IP session. And so we feel like that is a better way of more secure. Maybe in terms of time, maybe we should hurry up a little bit.
I'll point out that Emily and I have a slight difference of opinion about the wisdom of passing that one-time token as a query parameter versus a form post versus a header. But those are details that we'll talk about later.
Right. As you can see, I pointed out over there. So one-time use token is passed to the using HTTP GET because we don't know how what is the experience going to be to have it if we were to using a native browser, how that thing, because we cannot definitely do a post the token to the native browser, right? So that's another something that we need to.
And we can sort that out later. The other thing is if you with the VMware proposal. If you're not using the app info endpoint, you can't use the information from the app info endpoint to dereference the identity of the client application, i.e. who signed it and what its bundle ID. So that then forces you to sort of pass more information back to the AF to make that decision. So that raised the question. Having the TA take a bunch of information from the app info endpoint, figure out what the app is, and then pass a unique identifier or the scope back to the AF to potentially needing to pass a much more complex set of information back to the AF.
Right. But the source of truth is still at the AS.
Exactly.
Right. You just like.
I'm not disagreeing. I'm pointing out that that's why one of the previous assumption was that the information would go to the token agent, and the token agent would validate the app and essentially dereference the app ID based on information on the phone to some unique identifier versus having to pass the information that it gathers back to the AF to have it.
Right. But I don't think the spec by itself need to enforce that you must have app info. I just feel like we should be able to accommodate it both ways. If you actually have a TA which can handle the more complex, do the processing app info, you should do that. But because the source of truth is still at the primary AS, so we should still allow the AS to do the final entitlement validation.
The source of truth for the user identity and the entitlements for the user is the AS. But the application identity, the only thing that can do it is the TA. So the TA should have the bundle ID or the signature or the packet ID or what have you, or a specific thing to tell the identity of the app.
I feel I call that one validation. That's the kind of the app validation.
Right, so the app identity, app validation has.
However, the enforcement, whether I can, as the AS can issue the token for this particular so-called app one, is up to the AS.
Agreed.
Right. So let's just move on. I mean, we're open for open discussion. So welcome people to let's talk and see how we actually going to so it can be become standard and more secure way. So I'm now going to pass on to Kabir to talk about our implementation.
Excellent, thank you.
If it fails, that means it's real.
Yeah, so this will be a live demo. And John and Lucas on the dial-in, I apologize, you're not going to be able to see this because we're going to plug right into an iPad here. So Lucas on the line from our team actually worked very closely with Emily to develop the web app flow. And I'll walk you through, I'll take it up a level. Sorry, 1, 2, 3, 4, right?
Let me just write that down.
So let me take it up a level and just explain and elaborate on Emily's point on the problem we were trying to solve here. So with AirWatch and VMware, we wanted to improve the end user experience for customers who deploy both the product from VMware, that's called Workspace Portal, as well as a product from AirWatch, which is our app management solution in our app catalog. So the experience today for those customers is they have a Workspace Portal, which is just a single sign-on SaaS app launcher. It also does some interesting things. Not only does it include web and SaaS apps, but it also includes virtual apps and virtual desktops in this single launcher. So a customer would have to go to this portal to get their web apps, get their virtual apps, and then they'd also go to the AirWatch catalog to get all their native mobile apps. So we wanted to bring those together and do it in a way that if the device is managed by AirWatch and AirWatch knows the identity of that user, why do we ever need to prompt anyone for a login again? So when we were thinking about this problem specifically for web apps, the train of thought was if we think of a browser as just a native app and we think of the website as just a SaaS backend, why couldn't we adapt the NAPPS flow for that use case? So I think there's a different discussion on should we, but why not, right? So what we did in this demo is the first part of it is we brought all of the Workspace apps, so all of those web apps and all of the virtual apps all in a single view alongside the native apps. So from an end user perspective, they get a very simple unified view, and I see my mobile apps and all my virtual apps. I can install any of these and they show up on the springboard on the device just like they would a native app. Now, the way we're installing these are actually web clips. So it's not actually a native app that comes down, it's just a web clip. And what we do is we change the URL of that web clip to automatically launch in the URL scheme of our secure browser. Our secure browser then has the NAPPS flow implemented, and it becomes a very simple user experience. So let me use SocialCast as an example. I'll launch SocialCast. It'll automatically launch in the browser. We're using the NAPPS flow to authenticate to the workspace portal, which will then automatically single sign on into SocialCast. So very simple user experience. The end user also gets a side benefit of using this browser. If this is a SaaS app or a web app that's on the internal network, our browser tunnels them directly into that site as well, without needing a VPN or a Wi-Fi on the device. So from an end user perspective, it's a very elegant single catalog, all the apps in one place. You never have to log in to get to any of those. The virtual app side of it is also an interesting component of what the Workspace portal offers. So I can install a full virtual desktop, and it appears on my Springboard. You can see this right next to the VMware View app in the bottom right. You'll see that I've installed a virtual desktop, and this is just a web clip under the hood. I can launch it. It's going to do the web app flow to authenticate, and then the Workspace portal is going to automatically redirect me into the VMware View native app that can handle the virtual desktop, and I immediately get access immediately after a few seconds.
So the secure app is the app in the NAPPS flow, and the MDM agent is the TA of the NAPPS flow.
Yeah, so how we implemented this is we actually built the TA into our secure browser itself. And the reason we did that is if you implement it in a separate app, you get this experience of flip-flop, and it's nasty. Good. It's going to end up on YouTube later, I guess.
We'll have the NDA agreement signed on the way out.
Yeah. So a pretty interesting implementation. I think from, I come very much from the mobile side of it, and so the TA and AS and RA are foreign languages to me. But from my perspective, there are kind of two questions that we've been playing with at AirWatch. We can do it, but there's a lot of effort involved in building this web app flow, and if you think about what it really gets you, you're eliminating an authentication screen from a SAML prompt that you would normally get when you launch a web app, and then you're also eliminating, you're getting a longer-lived session, so after the 8-hour timeout of that SAML session, you don't have to authenticate again. So that experience is what you get on laptop or PC or mobile, and agreed it's better if we can eliminate that, but is that something we need to do, or is there a different way of solving it? Is kind of one problem. The other problem is this works very well for SaaS applications, but what we see for a majority of our customers today is that there's still a substantial portion of internal web apps that are NTLM, certificate. A lot of enterprises that are building these sites don't do OAuth or know what OAuth is. And so this doesn't really solve all of the problems for those customers. So how do we do that in a different way?
By the way, just to right now, Workspace portal does support those non-federated web apps.
Yeah.
So as long as you single sign on to Workspace can handle all the single sign on for you.
Yeah.
Vaulting?
I'm sorry?
Vaulting?
Well,
Similar to that.
Passwords.
Either that or have the same password for everything.
Sure.
Yeah.
That's federation.
Then the third thing that comes up is implementing this flow does require you to use a proprietary browser, and that has code in it. So if we wanted to, a solution like AirWatch or Mobile Iron or whatever, it can also manage Macs or whatever it is, right? So on a Mac, how would you implement this flow? Would an end user really want to use a separate browser? And so how do we enable that experience is kind of the question. There's a question? I'm sorry.
I was just curious if you maybe I missed it, but was there any portion of that actually started with the native app as the launching point? If I'm using a SaaS app or some other application or only for browser-based?
So what we implemented here is just the web app flow. We haven't implemented the native app, like a Salesforce native app flow. Was that your question? The first two scenarios Emily mentioned, right? Yeah, we haven't implemented that yet.
So the only reason why you had that secure browser was to be able to bundle in the TA portion to it.
Yes.
So if you were to just use a normal browser, which we've done in our course, and then our analogous to a TA is, so then we see the flip-flop. So that's the only drawback, right?
Right, so the question was, the only reason we're using the secure browser is to embed the TA functionality into that browser, as opposed to using a different browser and having to flip between a separate TA agent. And that browser that you use would need to know to flip, is the other part of it.
Right, I mean, yeah, you would have to call, or you have to call a server-side thing that again calls your custom scheme to launch, right?
Yeah, good point.
So maybe it's time for a break?
Yeah. Tell them maybe 5 minutes and we meet in...
We meet at
10:45?
Yes.
10:45.
10:45 then?
10:45, okay.
Worked. Cool. Introduce myself. I'm Blake. I'm here. Very nice to meet you. Tech lead for the mobile team. Oh, excellent. You've been working with Suja and Joseph.
Lucas.
Nope, I haven't worked with anybody yet. So
Hey, Chip, how are you? Can you share the slides? Say again? Yeah, so what I'll do is share all the slides from the speakers, and put them and I send out within 10 minutes. Okay,
I mean, iOS 8 may make it a little easier.
So we have a proposed flow for that communication we thought through using the package where the app is validating it. So when we get to that point on Android, I can walk you through kind of what we found out, both Bob and us.
So you're more interested in who self-selects.
So if you have a different idea.
I'm more interested in who self-selects. I've never had a problem causing enough.
It seems that pretty what you're doing is by having a custom browser, you're just using it as an interceptor for all your HTTP traffic.
So, are there any slides?
No, that's what I was thinking when you were saying that. We are actually, we can even wrap an app and we can intercept a 401.
Exactly.
That's exactly.
Yeah, and the thing is, if you put your interceptor on the actual OS level, then you don't have
So that's what iOS has done with Kerberos in iOS 7. And so the thought is if iOS 7 can do that with certificates and with whatever else.
And I mean, within the enterprises, I mean, you have so many, you typically have everything running through a proxy service.
Yeah, well, you
either have your browser, you set up in your browser,
proprietary
and try and access the web.
There are hundreds of problems.
Yeah.
Nothing else.
Which just basically intercepts all the HTTP.
So I think the point is if there's a way to do it on the device that you can do it in a proxy seamless way, then do it. But I think the point was the spec doesn't say you can't do it. So that's what we get.
Yeah, I think the spec is trying to be more open to non-enterprise solutions.
What I'm consistently hearing
a custom, like
the rest of the ecosystem,
a normal, like, oh, Facebook wants to use this, great.
What they,
then
the
it can
tools
do it
they have to
without
work
having
with at the
to-
iOS level
My mom on
are
her
very.
Right, but I mean,
I'm just trying to.
and those are the people who are going to pay for it. I mean, let's face it. So, I mean, if you want to do something for, someone else who's probably going to have a whole bunch of other corner cases that are going to break whatever you do, because they're not going to necessarily enforce anything, because they don't really know what they're doing anyway, they're not really a customer, because they're going to expect to download it for free.
If we provide,
So,
if we provide a means
just
for the EMM
provide a solution
pass
for people
that
who
email
are
address to
going
the
to, follow
account,
a,
that solves a ton of stuff, right?
piece of documentation that explains how to use it, and also will pay for it.
Right.
That'd be my thinking.
So, we talked about earlier apps being aware. Since most apps in the flow have always been kind of generally accessible and have launched the browser, the normal auth too, so the app launches the browser. Does the normal auth too, so browser redirects the redirect URL. What if we kind of set up this protocol, so the token agent has this default URL scheme, so that way it can always run. Then all clients could just normally call whatever browser they're going to call. And on the server side, you say, oh, this is where, in case there is in case they have a token agent on the device, try redirecting to this redirect URL, so you launch
the thing what everybody seems to have,
there would be then the token agent could redirect to the redirect URL of the app. Makes sense? Then all of two apps
using
custom URL already support that. They don't have to change anything. If they have the user passes the token agent installed.
All you need to do is
The authorization server could know, oh yeah, I'm NAPPS enabled, and I expect all my clients to have or not.
well, there are so many of those companies.
That's right. So
in the protocol, token agent.
Token agent. We'll let Apple
bring more people into this.
Right. I think police actually
Our apps so require that to visually bounce back
exactly.
So yeah, my thought would be if we do something along those lines, it ends up being seamless and everyone kind of gets it for free. We can just inherit all the two client apps that are
enabling.
On Android, Google, the Facebook active.
I know in the afternoon we have some.
But the original Android OS level was an attempt, an admission of Google and Facebook use to provide public APIs. We actually mentioned no, that was actually extremely limited. And we've all stopped using it.
Right.
I think it's sad about just saying that.
So I mean, that's really my main question out of today is there something we should be considering doing to make this UX easier on the UX side and then make the process for especially.
So our even in consumer space, we're more focused on either Facebook or Salesforce that are current techniques. Using instead of one-time iOS.
Yes, well, I hear the argument you're making. I'm also, I mean, I'm getting a different story from the EMM, so I need to resolve, what is it that either the EMMs are missing or that Android is missing to be able to support those use cases.
I do. I know.
I don't know if I remember. Anything else needs to be a bit more involved in ICF work. ICF should, in my opinion, use
I find it really interesting when you're talking about the one side of the
and it does 4-day digital swap.
Yeah.
So ITF.
So we don't have any guidance out there now that needs to get due.
There are documents that have problems there two types of iOS and Android.
Well, but that only works if it's the same developer for everything, or you're using. Yeah. That's right.
Google who wants to be the science.
Right. So it renders, I mean, the guidance has to be able to work for yourself on third-party apps that aren't signed by the same.
And that's what fascinating.
Yes.
But also we're not.
So are you staying here?
About how they're marketing.
No, but these guys are all willing. I mean, that's what always gets back to.
That's one thing that we would like to start with. As a SaaS product, we need to work. We don't see that.
Yes. Well, they,
And as far as customers who talk to it, never even find out. So the MDMs are serving us, their customers.
Yeah, so that's exactly what I want. That's the loop that I want to close here. I want to either find out, all right, what is the issue? Yeah.
Most of them actually came out of the SaaS space.
That's right.
That's what's part
So, I mean, more than anything else, I want to be able to walk away from here with a clear path to, all right, here's the message I'm telling the MM partners, here's the messaging I'm telling the Android work team, here's the messaging I'm telling the right.
There are a couple of different things. I don't see the Salesforce role they are interested in improving the UX around discovery. But the ones I talk to, they have no problems with continuing to leverage the especially if they use the main browser.
Well, and I don't, I don't, I'm not concerned about the one-time registration flow as the only thing. Although I'm definitely concerned about the notion that initial provisioning is going to require like 20 of these. Right, that's really ugly. Yeah, and I definitely want to make use of that. Where well, so okay, so some of these are SaaS apps, some of these are enterprise.
And that's
it's the intersection of all these, and then when we say, all right, so we've got this one use case that works for these guys, but this other use case for those guys.
This section, which then enables the fact, and then the server uses that as a key to come back and say, now, what's the one?
That's perfectly discussion too. I guess what I'm hearing is there's a lot of people that want to do stuff, but the overlap between their use cases is not always, it's not clear that we're converging. And that's a concern.
The question is one of those where it's only use case but a 509 funding of the device that happens to have
I do wonder
it was really
shared
can't put it the same way.
Just
well, do you understand why? I mean, iOS is a real famous case. You know why nobody uses the new based so it works if all you have is your own internal developed apps, right? I think everybody agrees that that's a solid use case. The problem is, well, that's right. Well, the problem is when you start mixing combination. Well, so this is what I'm hearing is there's no way to use any of the shared keychain models in a clean way that allows you to have SaaS and internal.
There's a seat next to me
cleanly work together.
Working together is what we're talking about participation. Once the apps are used in place, now we have ways
That flow is self-explanatory.
Yes, I know.
I don't think you even need to say anything about it.
Yes. Well, I was just.
The question, why is it so hard for the enterprise?
There were more errors than I initially expected.
Their own and
There always are.
third-party apps and patch authentication and have clean user experience, right? It's not. It's not for lack of standards. It's that there are, that there are a lot of potential standards, but that there's a big fragmentation in terms of which standards people follow.
Sure. I'm just trying to say, to get multiple usage.
You can actually switch
Usage of initial authentication. Once you get past that, I don't know of any problem with apps looking at it. I know
Yeah, I don't think, even when I'm distracted, we're worried about one app talking more than another.
So just initial, you have to.
Yes.
So either I don't,
We said we do
user to the app and the ongoing reauthentication, right? All of these
quite often. It's interesting.
she's still there, right? She's still there?
So it sounds to me like the big question we want to get to here is what use cases
You can start otherwise.
are we truly
So we're gonna start again, Dave, Eve, you can take a seat. We're gonna start. I had to call you out. Okay, so I'm gonna hand over to Naveen, talk about what Google has done. So there was a brief period. Keep talking to the white people here.
I had already switched it to the right place.
Oh, sorry.
That's okay. Start. Yeah, we are already 5 minutes past.
Yeah.
Hello, I'm Naveen from Google, and essentially give a quick overview of what happens on Android and iOS app. And we had to solve many of these issues in the couple of years back. And many of these things are actually rolling out, but work. So, in fact, most of what the NAPPS is, these flows would look pretty much similar. There are some minor differences, and I can call out between iOS and Android, but we have pretty much tried to do the same thing. So on Android, what we call account manager, which is essentially the token AT in the designs, the token server, or the token manager, which is essentially authenticates the user to the authentication servers, and it gets a long-lived tokens. Basically, that's step number 1 and 2. It gets what we call a God token. Essentially, it has the power to generate full sessions to Google servers in that case. And it holds on to those, and it can continue to get refresh tokens. Now, what happens is, I did want to call out the device policy part in a few seconds. Then any of the Google app, which if it needs a token, it would go to the account manager and say, hey, I need a token, and here are the scopes I need. It is going to go back, ask I need a token for this particular app. In this case, we know these are Google apps. What it sends at this point is essentially, it's refresh token, what this had gotten, and the app name, which is the package name, and basically the cert or the public key, the signatures. Signature plus cert, signing cert.
Can we do this?
I think. Oh, that's fine, I can, yeah, I'm not writing that much more. So on the server side, we verify that this is a Google app and it has the right permissions. We essentially just issue you back an access token, which it passes back to the Google app and it continues to make calls. There are no approvals or anything else required. So all the Google apps you open up, they basically have access to, they get a single sign-on.
Naveen,
Yep.
can you explain just a little bit more about the signature and the cert, like where the cert comes from or its provision and what's signed?
So each of the app is signed by the developer, right? So that's basically, so you could always sideload a app which is claiming to be, com.google. something, but they would not be signed with a Google cert.
So the entire app binary is signed
right
by the developer.
Right.
Okay.
But merely including the signature of a valid Google app does not prove that it's the valid Google app that's requesting the token, right?
Right. So we do have the cert validation on the server side, so we can say whether this app was supposed to be signed with this cert or not.
But the app is not signing anything to prove that it has.
App is not signing anything. Okay. Yes. App is basically so. The token, the account manager is essentially asserting a bunch of information about who's making the call. And this is essentially the trusted agent. So as long as the OS is not hacked or what we call, this is trusted, we can, the whole thing works. And even if the whole thing is hacked, the worst thing you are doing is to your own account because the refresh token for the account is the credential which is making the difference. So it doesn't really matter, if the OS is hacked, you can screw up your own account, not somebody else's account.
Quick question.
Yep.
So the account manager is built into the OS specific for Google Apps. Is that, I'm sorry, maybe I missed that open part.
So the account manager is what we call, what's the JMS code? It's essentially a privileged app. So it is not built into the OS, but it is an app which is essentially privileged, which can do a little bit more than without the other apps.
And
so
it's now called Play Services?
Yes, it's basically Google Play Services app.
Okay. The other apps are making a call to the account manager via intent, or is it something else?
No, so they do expose the API without, so that, I'll come back to that part, let's see. I think, I'm not sure I can, so there are different mechanisms.
It's easier to describe a third-party app.
Yes.
Talking to it.
Right. So that's basically the single sign-on. I think it's worth mentioning, if you are an enterprise customer and you enable device policy, the way that works is you could log in to Google Apps and get a refresh token. But then the device policy app, if it's not there, then if anybody tries to get an access token when it goes back, this does also a check and say, hey, does this customer require device policy or not to be enabled? And there is let's say, device policy database which can say, hey, this device, is it basically enabled with the policy or not? And in that case, it's not going to give you back an access token, but it'll show you an error message and say, hey, you need to install the Google device policy or whatever the app is required. So when you install the device policy, it does all the checks. It basically updates, makes a call to the device policy server and says, okay, this device is verified, and makes a note in the database. So then when you go back and repeat the call, the whole thing will continue to work. And this app continues to make a call every 30 minutes or so to get validated. So if you uninstall this, and within 30 minutes, your other apps will stop working. These access tokens are generally, depending on, they could vary between 30 minutes to 24 hours, depending on various security policies and so on. So they are not fixed 1 hour tokens, or they used to be fixed at some point, but they can change. So that's for the Google apps. Coming back to the third-party apps, they essentially make a call to the, so there are a couple of ways, and some of the parts are changing how you make calls. There is the one which is in the OS itself, which is the Google Auth utils, which essentially channels to this particular app, or you can make calls directly to the GMS code, which makes a call essentially. This goes back to the authorization server and says, this app is making a call, and here are the scopes it's requesting. There are two possibilities. if you had approved that app previously on a different device, or if you had approved it on the web for the same developer, we could just return you back an access token and you're done. But if you had never, we had never seen this app before, or the user and you had never authorized, you would get back a, sorry, but here are the scopes, or here are the text descriptions you need to show. In that case, the account manager, well, then it's a little bit more complicated. The account manager doesn't show it directly, tells you back, and the app has to throw back an intent and say, hey, display this permission. And it will display the permissions using those strings. It's a native permission in this case. And the user says yes or no. Once the user says yes, the account manager will make a call back and say, yes, the user said yes or no. We record the consent. And you go back and repeat exactly the same flow back again without the step, and you'll get a token back. So, and the app can continue to make calls to any other scopes they need. In the future, let's say the app requires a scope number 3, then the same thing would happen. You would not get the token back. You need to show back a string for just the scope 3, and then you would basically continue from that point onwards.
Is that green RS an arbitrary third-party RS, or is it?
Well,
Google?
I think these are mostly for Google-related things, for Google access to, Google.
We try to be
APIs.
completely agnostic to how the third-party apps talk to their home servers. We give them a token, and maybe it's sufficient, maybe it's not for authentication, how to make their kind of trying to.
I meant more that your account manager is calling your AS. So the implication is that, it's an RS that trusts your AS.
Yes, this RS generally will validate the tokens through the same.
Gmail. Those are all sort of free, set up their own APIs, and you just handle the authorization.
But if all the third-party app is doing is using Google for login and not for other stuff, then obviously it's not talking back.
So let me quickly go back on the iOS. Pretty much.
Do you want to talk about the identity token?
I'll come back to identity token, I think. I'm not sure it matters that much from an access token versus identity token perspective, I think. But on the iOS, the Google app
the identity token can help them sign in back to their own RS.
Yes. So I'll come back and let's talk about the identity token separately because that is a slightly different flow. So on the iOS, pretty much exactly the same flow continues to work. The Google app, you as a user will authenticate to the server, get cookies, and get a long-lived refresh token on the number 2, just like that. And if a third-party app requests a scope A, and here is also, I did want to mention, somebody said, hey, how do you securely talk to each other? We implemented something called a simple proof of possession protocol, which we have a spec in the ITF as well, where the app will basically send a verifier along with the request of scopes. We would make a call back. Again, one possibility. So in this case, given talk to this app, you need to do app flip. We decided the access token is not going to continue to work because in this case, the access token comes back and says, hey, it's valid for 30 minutes or 60 minutes. Then you can go back in the background and refresh that, get an access token. In this case, you always pretty much require a code or a refresh token. So in this case, whenever you request a code or a refresh token, we would basically say, hey, you need to show consent page. And in this case, the account manager app or the Google app will actually show you a consent page where you say yes or no, and then record the grant. And then in that case, comes back and we give you back a code, which is exchanged by this app for a refresh token, and then you make a call. So that's kind of a big difference between this model versus here, where you end up getting a refresh token for any app. But pretty much the other device policy stuff is exactly the same, where if you did require a device policy, if any app made a call and tries to use the access token, in fact, none of the Google apps themselves will actually get the access token. The refresh token may be there, but they would not get an app-specific token if the device policy app is not there. So essentially, they don't work. It'll show you an error message. Once you install the device policy app, it would make a call and validate that the device actually is valid, and then the whole flow continues to work from that point onwards.
So if NAPPS were to follow that model, the TA would return different things on the two different OS?
Well, it's ultimately a token, as far as I see it. Whether it's code, refresh token, or access token, I don't see that much of a difference.
The way I understood it is on iOS, the app gets a code or a refresh token that it can then exchange on its own,
Yep.
and thereby avoid the UX of the flip.
Correct.
But in there, you're not driven to enable that on Android, so you just return the access token.
Correct.
So the TA and the AS presumably has to sort of be aware of which OS the context is.
So the OS, I mean, these TAs are definitely different. One is built into the for Android one. So that's the big difference in a model perspective. I'm not sure. Well, yeah. So I'm not sure how to merge those two together.
Well, my question is to NAPPS is, do we do the same? Are we led by your experience?
I think this is where it is helpful to go to the ID token, because most of their use cases aren't an app just doing the Google Research Server. It's an app doing login to its home server. And the ID token, I think, is treated more like a code, right?
So it means, yep.
So in the Android architecture, so where the TA will be, if you integrating with OpenID, so where is the TA, the token agent?
If you are integrating.
What he's called an AT, I think it's pretty equivalent to
that should have
that.
been that is, yeah. Yeah, we generally have been using the word account manager internally, so that's okay.
I think NAPPS is mature enough for us to argue about terminology. Every step does.
Yeah, that's a yes, yeah. Thanks.
Okay, so how the account manager to do the federation SSO?
So again, in the spec, this part, how do you do the authentication to the server is left separately, right? So there are multiple ways. In most of the cases, for example, in the iOS case, it does an embedded browser view in the two Google servers. So let's say if you were a SAML customer, then Google server will redirect you to your SAML IDP.
The account manager only supports OAuth at this moment.
No, so this is bundling a lot of things. This 1 and 2 step can be 10, 20 steps depending on who you are. It doesn't really matter. So I'm not sure I understand.
Right. So for example, company A, enterprise A say I have a Google Apps and also I have Dropbox. So when I click box, it pops up the hyperlink credential. Then how account manager to handle the federation so that the Google Apps automatically log in.
Right. Go ahead. So I think, so yeah, two different examples. Is what's our big company? Browning. It's our company.
Yeah.
And you've got Todd there. Todd might be using Google Drive.
Yes.
Right. So let's just take the simple one. If he's using this, a Google app,
yes.
And our account manager needs a Google long-lived token that this can use. So this does OAuth to plain vanilla to our home server, which means opening up an embedded web view. In that embedded web view, Google asks the user, what's your email address? He says, Todd at Browning, and we say, well, server side, we know that's MIDP, we bounce to it, we come back. We've got a long-lived token here, and that supports Google Drive, but at that point, you're only Google Drive. Right. So your second question was about Box.net. That doesn't, let me describe what does happen, what use cases do happen today, which is now maybe Todd decides he wants to log into TripIt, and let's say that his company hasn't signed up for TripIt. He just decided to use TripIt himself because he travels so much for work, but he might use TripIt with his work email, right? If you go to TripIt's Android app today, TripIt's Android app has integrated with Google's primarily what we call Google Plus sign-in SDK to do something somewhat similar to NAPPS, and I think this is what we should talk about, where there's a way for TripIt's app here, theoretically Bots to do it, to say, hey, I want to go, the user within my app told me they want to use Google. Let me go to Google and let me ask for a ID token from Google that I can send to TripIt's home servers, and TripIt's home servers can say, all right, I'm willing to trust that. I will now give you a TripIt basically refresh token back to the app.
Okay.
And that's go from there. So we could talk about how TripIt does that. So I think that's what
I was going to talk about that.
So basically, the strong assumption is Google is the IDP. But what if the company doesn't use Google as IDP, use Centrify or Ping Identity as the IDP, and then this.
So that's to say that TripIt supports multiple IDP options today. Facebook, Google, Twitter, etc. And it could be anything. So I'd say if you look at how TripIt talks to Google, and if you understand that model, that's a model theoretically TripIt could use with any IDP.
Right. So, but what if people say, "Oh, I don't like Google domain. I use Ping Identity as the IDP."
We believe technologically the way they talk to us, because it's pretty much standard OAuth techniques and ID tokens, it is a API model that they could use with anybody else.
Exactly. So the account manager itself is a system service. So
no, actually, I think when he walks through it, you'll find
a bunch of authenticators, right? Authenticators. So Google provides the mail as the default authenticator for all the Google domain application.
So the flow that Eric described would work for Ping software acting as the enterprise IDP.
Right.
And that's what we're trying to enable with NAPPS. So that TA is one optimized to talk to Google authorization server.
Right.
Right. And support Google RSs for the most part.
Right. But Brown and Company could build their own TA up there that supports the same API interface if TripIt.
And when provisioned down to Todd's device, it would know what AS to talk to. It wouldn't be a Google AS unless they use
Browning's TA is what talks to Browning's AS.
Right.
So why don't you explain how?
I think the ID token use case, which Adam talked about. So one of the problems where we have run into, and it's not, it's basically a use case. So here is the app. Generally what happens is apps, of course, have their app server. And on their side, they might end up keeping a refresh token, let's say for Google, on their backend, instead of just keeping on the app itself, because we started the whole OAuth use cases from a server-side code flow. So imagine what happens. You have an app for the mobile phones. You have an Android app. You could also have a browser, and the user logs into the app server. Let's take an example. Let's say, I guess TripIt is a good example. Yes, yeah. So at this point, when the app is saying, "Hey, I want a token," it doesn't know whether I already have a refresh token for the user one or not. So that makes things complicated. So it doesn't know what to ask for. And the part is, no matter where you start. So you could start from a browser. So if you started from a browser on a desktop, you go through the OAuth flow, standard OAuth consent, you get back a code on the server side, and they store a refresh token, and you're done. And the server basically has access to your, let's say, calendar API. But if you started on an app, what do? How do you get a code for your server? So you can get a code for yourself, for the app itself, which is without the secrets and so on. But this one is much more complicated, and it makes it worse because you don't really know what to do in the first time request. Should I just ask for a code every time when the user is signing in? So you don't even know who the user is. So one of the use cases, if you were using Google Sign-In, you could do is, as an app, can ask for an ID token. So you can ask the account manager and say, give me an ID token for the user. Essentially, which says who the user is, and it's signed by Google servers. In that case, the app can send it back to the server and says, here is the ID token, which I got. Essentially, what should I do? And in that case, if you already had a refresh token, you could do the server-based flow, and you don't need anything else, and you're signed in. But if you did not have, the app server can say, hey, can you get me a refresh token for the server flow? So we recently enabled on the iOS side to make a request which can basically say, hey, I need a code for my server. And you can pass the information about the server, where you would get essentially two codes back. One, to give it back to your home server, so you can reply the code here, and this is actually going to send this code with the secret to the authorization server and get back a refresh token and store it here. And the app can get its own code if it wants to.
That part doesn't exist on Android at this point, but this is an interesting problem: how to make sure the servers get the right refresh token for those apps. I don't think we have talked about it in the NAPPS use cases, but the ID token part, what we were able to do on Android. So Android and iOS both support the ID token use case. You can request an ID token, and we would give you an ID token without a consent page. As long as so what happens is, if you are saying, I want an ID token for my home server, we look up and say, this app and the home servers, what we call the client IDs, they are in the same project at Google. So essentially, we can give any app an ID token for the user, as long as the user is willing to give the email address to the app itself. So that ID token essentially
in general, their systems want to be as agnostic as possible. Once the authentication is done, they want to be as agnostic as possible to how that happened. Everything else in their system should stay unchanged.
Just separately, one thing to call out, the NAPPS doesn't address the whole consent part yet, which is the consumer use case. And for our use cases, most of the apps end up requiring a consent, which is essentially showing the token agent or the trusted agent on the device. So we would love to add that use case in the NAPPS to make sure the consent.
Usually, if you don't need the consent, you want the device policy check, which also described how we're starting to do. And again, we also need to be able to separate out.
Chuck would argue that consent is not specific to consumer.
Right.
Yeah. So I think it's a matter of, the consent part could actually request more information and other things and so on. The device policy, can gather up, especially on the consent part. You could run through some tests to make sure it's a real device. It's not somebody. I mean, it essentially can give you some more signals which are required, maybe required before you can issue a separate token for that.
So I was away a couple of minutes for the meeting. I did do it.
So the broadcast, nobody. Oh, there are 7 viewers.
Who was that?
Not recognizable.
Who's that? Who just spoke on the conference call?
That mic might be turned off.
Is it turned off? Red, yes.
No, it's all good.
But green now. It was red earlier.
Probably John getting another brand new call again, particularly talking to us.
All right. That's it. I think I've taken more than 20 minutes. Cool.
So are there specific lessons or patterns that NAPPS can learn from?
So I think that's the whole consent part is one. I think I'm not sure where this whole code flow for the server comes into the picture. Ultimately, the apps are not on their own. They may work together with their own server. So for example, I think in the beginning we were thinking of the apps itself, pretty much they are container, but they are a whole other ecosystem. So we need to figure out how to make the state of the app in a similar way, whether you came from a web server use case or whether you started on Android, whether you started on iOS.
they should all be able to reach in a same state. And which in our case turned out to be, let's say, requiring a refresh token on the server so they can do the backend calls when the app is not there or when the user is not active. For example, the Tripit case, where they are fetching data to that.
So one of us, you notice up there, we have two boxes. We have Google Apps and we have other apps. You want to say, I try to put myself in an enterprise shoes context. So an enterprise is going to have their own custom developed mobile apps, and they'll have the external SaaS apps that they use. Sorry. So they'll have two class apps, apps they build themselves and apps that they are subscribed to. We've had to use pretty darn different techniques for them. And right now, NAPPS has written, I think is merging the two a bit more than is probably realistic. I think you're going to end up having a NAPPS profile. Here's what you should do if it's a custom IT app. Here's what you should do if they are a third-party app. And so I think we could write those two a bit differently, as one guidance. And then as Adam and Naveen were saying, when it is not your own built app, when it's somebody else's app, today the SAML equivalent is you're trying to get a SAML assertion to them, and once you don't know what they did with it, right? Like OpenI OAuth 2 tries to be very agnostic to how authentication happens. So you're just trying to get that app, that enterprise SaaS app or that gaming app, something like a SAML assertion for you, but it's an assertion. What they do with it is really then up to them. And you have to give them a lot of flexibility in what they do from that point on, right? There's a separate thing that maybe we could go through later in the day, which is just we're talking about it, the UI discovery problem of, if you do launch the enterprise app, Tripit, et cetera, how does it even figure out what IDP you want to use? Is it Facebook? Is it Google? Is it Browning? Is it Acme, et cetera? That's where the account chooser type stuff, but we could talk about that issue as well.
I'm just going to mention one last part, which is if anybody did a search of NAPPS on Google, the first link is National Association of Professional Pet Sitters.
So we work with John Bradley. We have to watch.
Right. Thanks. Okay, you can do that first. Okay, so lunch is here. So maybe while Centrified setting up, we grab lunch and we go from there. Okay, cool.
So you were just going to say, the team was going,
No. Right when you all eat lunch in the
This part is not
There's only so many ways you can guess word.
The main takeaway I'm getting.
I don't know, we did pretty wide variety.
You're never going to remember it.
The app basically says
I had better luck without it. So I'm still,
I'll come back
to a lot of
So let me go back to the original early part of the discussion. Those 2 and 5 were Yes, well, and in particular, what is this? Right? It seems like almost everyone is in a way that you expect still trying to find it, the web browser shared security contact built this, and to me that's backwards.
We clearly understand it.
And the account manager is not the same.
That's what I'm saying. I'm looking
Forcing it through the web browser.
and that's the, or if it is different, all these arrows are the same. And just as I would first pick that there will be different parameters, and then maybe slightly different formatting or something. But this guy didn't know where he was going.
So the lesson me,
Trigger on
is
iOS
that
and proof of possession.
for usability reasons, led to the refresh token to the apps.
But it does.
So is it, for the sake of consistency between this and this,
Plenty of
is it better
enterprises
to feature the refresh
employees who are
tokens and
subscribed to Trip
with
There are lots of problems with that. I think it depends on the semantics of the message.
And how does the capture work
dealt
in
with it over there.
that scenario?
What if it, can do, these are understandable.
I saw that.
Because right now, this AS has to know, oh, that's an iOS.
Right.
Shit, I think we don't like giving no idea to that. Let me ask the
Derek, I got the sense that you insist on the refresh token.
No, we have to. There's nothing, we have no other option.
Nobody,
Well,
if we get an identity token that could be used to.
They do expire.
Sorry, I'm just gonna try to get it right.
I love how everybody's taking pictures. And they're gonna look it down and play it later.
We're gonna come back and
What? It's insane.
Yes.
Well, I mean, I get accused of UMA being complicated, but this is like.
Functional pieces, like your device
But
policy.
none of this now.
We all want
That's
to
what
do
we're fine with.
Yeah, okay.
We are quite sure this is.
The basic part is that
Yeah, we're.
So then the critics is this something where I do need to have
it's exactly the same.
and then the browser may do the same. Or is it somewhere I can use local UI to talk? Or is it somewhere where I
You want to make sure this is.
Yeah. Because we need some for here.
These are overlap.
But yeah,
Is managers talk about security between an Android device.
So let's take
iOS and they want enough difference. They can say,
And
we'll
you
give iOS a
starts
token,
out.
I will not give the browser token, and I will not give Android a token. And they want it, they absolutely want to say, yeah, I have this function, and here's where it can
Let's
run.
follow up right
And
now.
here's where you can
Let's
say
do
to the
this.
Based on device
they want to control your solid.
They start out
They have to know where, what device is going on.
that figures into device
Even-
policy, right?
even
It's
if-
trusted device.
That's over there, they want it over here. They don't want it out of the box to go here, they don't want it to go out of the box to go here. They treat them as
that.
You can manage that with respect to the payload.
Login from.
Right, I'm saying you can't be completely opaque from the device that it's going to.
Yeah.
But a
Even
token
if the
agent never
protocol.
speaks for more than one device, right?
User
Token agent specific to device is
So the AS is gonna know whether it's an Android device.
And that's what I'm saying.
And the apps should have policies that say, well, okay, this is an Android device. That's fine. I just argued that these protocols.
Very,
Yeah, but no, this isn't a chapter, so let's just say that every.
They were
their own
identified.
application.
Okay, I think that's what he's about.
There might be tweaks.
Well,
How much
They
are
are very
your
best to make.
how much variance is there?
I'm using our artist use case because it's the
Yeah,
one
which
that is exactly which is.
For example,
this
interface
Here, it's environmental context.
Yes, that is different. That is here, or it's barely today, the authenticate story here as part of something to enable or
Yeah,
disable.
which,
Like,
and that's what I'm saying right now.
But then when we go to search here, we have no idea what the search of the app.
So he's detecting the client context
Yeah.
and deciding what to do on that basis.
Let's say they have.
Yeah.
So what's required specifically, they can call, it just tells you the bundle, right? That's all you can do.
When this calls this in iOS right now, not going into what's happening in the future, I know who called me based on a bundle ID, which is validated via a search.
And
When I call them,
even though
they know who called them.
we might have
What
already.
what they don't know is when they call me, are they really getting me? And what I don't know is when I'm calling them, are they really
Yeah, so that's why I think
There's
Yeah,
no way.
that's the missing piece on iOS.
So what we ended up doing is, so the app just identifying the verify.
That's exactly what we're talking
but Emily talked a little bit about it. So with this testing concept, when it calls this for code, it has to pass some random session. It's not a random number that somebody we want to do. It's one transaction, it's random, and it actually has a little bit more in there, but it has to be random. Back and forth, and they have to store the part of the so they want a response contract, because if you look at it the simplest way, in this call, we'll assume we're coming to be initiated. Sorry, just this passes the random number. Random number. Go to allow me to say, here's a key to decrypt. And this may choose not to use it.
Well, once again, but that different parameters might be appropriate.
And I just want to be sure that I think we are.
So that's kind of large difference between extra parameters and extra response. So for example, you make a call to exchange the refresh token, it does require a verifier. So we ended up
I think the conclusion we came to
for fixing that part. I think it's worth calling out.
So those are things that extend.
This is interacting directly as opposed to this.
So this one is
it's a solvable problem with atomic clock. They understand that they do something they try to literally just copy the flaw and point down the disk. But then our service says, shit, oh my god, we're copying the credentials.
That's going to discourage us. So and that part in particular, I mean, this gets down to how does the EMM kind of do that hands-on between one and another.
The Skype confessed. Remember, the Skype was very supportive. So anyway, okay, here's the word of the and once you authenticate all those pieces, then you just find it directly. I thought that so this thing started out of you're using the website.
And it wishes to now make your rest calls or quote have the phone conversation.
And that's what Skype does.
So well, I think I'm answering the whole question now.
Because there's a trust relationship.
There's not a shared security context between some of these
And
early
then there needs
applications
to be enough of a trust relationship
provisioning
but
the
not
identity.
necessarily
Not enough to be able to do that in confidence.
And that's what they're doing
at the lowest,
and that's where I'm caught. I'm offering suggestions only because I'm caught too. If when this starts to hear, and I'm
so inherently, so our system
just
just
I'm trusting the OS, and if the OS tells me it's red, or if it's application 1, I believe it's application 1 because I can validate that video. But it can be signatures to go to I can't do that. I can't do it.
And so the reality is
that I only do this platform.
There's two types of trust, right?
The underlying problem
say this is
is
a
one
good app.
of security
It's a
concepts
valid
and
app.
transit trust.
But the TA also has to know
put
that it's
aside,
an
it gets
authorized
referred to that.
Well, that's right. But he makes this call here, and this will be with the TA. The TA, I'm going to get a request for a token. I'm going to ask him.
So for those 96%, they don't
I don't have cash out here.
They have to
It's only cash. The current flow for me is sitting right here. Is that one a good app? Because I can prove who he is by the trust of the OS. He can prove that he trusts me by keys and things that we have. He goes out to his policy and says, is this a good app?
I see where you're coming from. Now I understand where you're
good app.
putting this on.
Authorized app to do what these parameters need to do at this time of day, from this IP address, on this day, and my system has a risk score of low. I mean, it can be, don't think it's just good app or bad app. It could be based on a whole.
Once again, it's not good or bad, it's, do I issue a token?
Can I issue a token? Exactly.
Right? Based on all the context we're talking
He
about.
may be calling out for complete risk-based authentication, or whole other things of, you know what, I got a whole bunch of bad passwords happening in the last hour. I'm going to require a second form of authentication for these, or whatever.
So what is that? What I think we have to sort of resolve is, what is the appropriate amount of complexity in the apps? Because in the simplest model, they get a token, they're good to go. But now we start giving a refresh token. So we start requiring that they include a verifier.
One
Maybe
thing
in
you
the
could
future
do
we'll
on
have
this,
a common.
one thing you could do on this side is have the TA compute an MD5 on this. But basically just like Norton does. It has a database of good known MD5s for apps. And it could go, oh, okay, is that an MD5? I know about
MD5 with the package name?
Oh, no, it actually
System
just
doesn't
compute.
give you the MD5 of other.
Oh, I know. What I'm saying is the TA could just compute it on the fly, yeah?
Use
No.
the same box. This has to be random when he calls, so that anybody who, nobody else will know what that token is except him and me, and I know who he is because I trust the OS to tell me. I don't need to do an MD5. I use the certificates of when he registered that app, and then I'm just going to use bundle name or whatever name we want to use for policy. The document is all done, and it comes back. I have
So your
to give
concern
it
is
to
not
him.
that this app has become compromised at any point. You don't care about that. You're just saying that once
It
it's
is
installed, doesn't have to-
possible on iOS.
Yeah,
It's
it's
that
siloed
one, for me to load another app and it'll say, I have one.
Exactly, that's what I'm saying.
And when I return, I can't guarantee which one of those goes to. So, I want to be sure whoever it was that called me, that I know who it is the
But
only
it
one
relies
who
on
can
the
use what I
OS.
get back. It relies on OS.
Yes, it doesn't have it.
Well, on there I can do it easier.
Yeah, on there.
You're using URLs, but I'm pressing the OS. He's calling me with the URL saying, when he called me, I know exactly who he was.
The frame, number one, you already know, it says kitchen area in the fridge. So if you want to get something to drink, it should be over there.
Okay. So I think we're going to start with the next session because, and then we'll come back to it. Yeah, it seems like there is definitely interest in spending more time on it. It's going to work or no?
It'll be 10 seconds.
Oh, wow. You planned it out.
Okay, my name is David McNeely with Centrify. I'm in product management, product strategy now. I have a couple of other technical people that can go deeper than me on technical questions. But we came into this space a little bit differently than most of the others, I think. And I just put this slide up just to highlight, one of the things that we were finding, and one of the reasons we started working with Samsung is because we found that the operating systems on the mobile devices were getting a lot more secure and starting to provide containerization. I think the best representation of that is what Samsung's done with NAPPS built into the platform. And one of the main reasons for providing single sign-on in that container is because the container was designed for business purposes. And much like my laptop that belongs to Centrify, and of course the IT guys joined it to our AD environment, I'm allowed to unlock the laptop and gain access to all the applications. And all the applications I launch and they just work, I get single sign-on. So we wanted that same experience inside the mobile container if the mobile container was created for my business because my business created it, right? So there's an MDM API that lets me create that container. I put this up here just so that you can see, all my personal stuff has got, david@mcneely.com or my personal Gmail account. But anything that's inside that container, it should be david@centrify.com. And so the point is we don't want to give the users choice as to what their identity is inside of a secure environment. So we want to make sure that mobile applications all work the same. I think we have a very common goal here for that. As we spoke with a lot of the ISVs, and we've spoken with 50 different SaaS ISVs, and the biggest challenge they have is they don't want to build two applications, one for business and one for personal use. Ideally, one app would work across the board for any of the different use cases. And further, they didn't want to build one for our container and vendor A's container, vendor B's container, et cetera. That becomes a big problem. But just like on Unix and Linux, Mac, and Windows, the authentication system should be pluggable so that it would support, my enterprise's identity provider or your enterprise's identity provider, because we're all going to be different. We may have something that's on-premise, or we may have something that's hosted. And it should work for any of the different use cases. So just at a high-level flow diagram, first of all, sorry, the font size is small. The installation and configuration, we're assuming is taken place by an MDM because the device has to be registered somehow. Somehow the enterprise is going to set up management of that device. That usually starts with an MDM, whether it's IT initiated or the user initiates, or if the IT is locking down a device for dedicated functions. There's a lot of different use cases, but that's where the identity provider, the client, would get put onto the system and configured. So what we're doing is really introducing this framework that goes in the middle, only to sort of abstract how does the application call and talk to identity, much like PAM and NSS do on Unix and Linux. And then on the bottom side of that, having the identity provider being plugged into that framework. Again, we're sort of looking at this like we look at any other operating system. And I think that's the major thing that's different here. The first time any application makes a call through the system, the token agents, in this case the identity provider client, would make the first call into my identity provider, authenticate me, and then provide along the credential. In our case, our example, we're using a PKI cert. It lasts for a year. Of course, we can revoke it if the employee leaves the company, but we can auto-renew that as well. That enables the rest of the flow to work correctly, where the user launches the application, it makes a call to the API. API can then turn around and tell the identity provider client to go authenticate David, make sure he's still good. In the right groups, make sure the calling application is the correct one. We verify the identity of the calling app and associate that with its backend service. So there has to be a linkage there between the two, so that we're not granting a token to a rogue application on the system. And then once we do that, we're handing back a token. Now we designed it to be token agnostic, so it could be a SAML token, it could be some other token, but we're assuming it's the identity token handed back to the client. So at that point, the Box application can then go talk to Box service. They'll do whatever they need to do to validate that identity token and provide the user access to the service. So we have that working for Box. Let me exit out and show you the hopefully that will focus. Yeah. That's on the personal side. I don't care. I'm not keeping anything that's secret on the personal side. Yes, it's supposed to have this invert capability. Nice. Can I borrow a piece of paper? Only because it's going to slide around a bit. Hopefully everybody can hear. Okay, so when you switch to NAPPS, it requires a password. I'll type it in. Yeah, I saw Chuck do this earlier and showed everybody his password last time. Okay, so now I'm in the business environment. Once you've unlocked to gain access to the business environment, you can switch back and forth pretty easily. So this is the main difference between Samsung and iOS. iOS does have sort of a containerization concept with managed apps, managed accounts, but no visual representation of what is containerized and what's not. So all the icons, have these little things on them. So I'm going to launch Box. I did a logout first, so you can see it saying log in. So really all we had them do was to take their code and right before they paint the login screen, make a call to the SDK, ask, do we have single sign-on set up? And if we reply back yes, they know that they can ask us for a token, we'll go get it and hand it back to them, they're on their way, they do their thing to the back end. If I were to go back in its settings and log out again, cleaned up, I can launch it again, it's going to go through the exact same process. It's inside a container. The identity for the user of this application should always be david@centrify.com, not of any other user. So I should never be able to somehow figure out a way to log out of the system and get back in with my personal Gmail accounts, because that would create a hole inside your container, right? Data would leak out of it. I would then be able to open up attachments, save them to Box, and by the way, it's going to my Gmail account. That's just wrong. That was the thing that we were trying to protect against. That's the main thing about creating a container and setting up authentication in this way, is we don't want to give the user a choice. We want to make sure that the user is always authenticated. Now, this is just a sample app, and at every single launch, it just simply asks who's the user so I can display it in last logon time. We can also build it in such a way that we can use that same data pipe back to the identity provider to go pick up more information. That pulled in real time out of Active Directory, and it pulled up all my group memberships. And we use those for access controls to a lot of different things. But if you think about the app developer that came from the Windows side or the Mac side, moving to mobile, he's used to being able to ask the OS, what groups are you a member of? So I can make authorization decisions inside my application. And once he's made the right authorization decisions, he can now ask for a token, he goes get a token, and this is just a sample app where we just talk to some web service in the back end and go pick up data. Not very complicated. But
don't they need to modify the app to remove the sign out and those functionality?
They didn't have to modify the app very much.
So how do you remove the sign out button and stuff like that?
They didn't need to remove the sign out button. So all their sign out button would still work. It's just that when you sign out and you close and scrub your cache of all the other tokens, it's going to go back to the start process, your start login. So it's wherever you do login, we just have a check to say, is single sign-on set up or not, so that you could flip back to the other. So just looking at this in a little bit more detail.
The app could ignore the single sign-on setup. It could show its own.
It could if it wanted to, yeah. I mean, the goal was to make it easier for the app developers so that it would be easy to integrate a higher level API that was very agnostic with respect to token to go say, tell me who the user is that's on this platform. And so our view was a little bit more like on the operating systems where you can just simply ask, who am I? And you can do get-in functions or directory service calls like you would on Windows or Mac in order to find out other data about the user.
But if Box wants a single app to work both when a TA is present and otherwise, they have to keep those other UI programs.
Right. So they have to keep their other legacy mechanisms, but we would like to try to eliminate the, click here for if you have single sign-on. Because at that point, you've given the user a choice that we don't believe the user should have if he's inside a corporate managed environment. And so for that reason, the calls, there's 3 of them here. Get user information, get user lookup for attributes, and then get security token. So if the first one succeeds, at that point, you can then go back and ask for security token. Token agnostic design, it's up to the application to transport it to the back-end service. But ideally, the app vendor only needs to worry about one version of their application that would support anybody's other identity provider. Now
So for the app to call out for identity information, what's it going to use that for? I mean, ultimately, I would think it's the server that's going to make the authorization decision about, based on roles, whatever, whether it gives you data or not. Is it customization of the app? Like, why would the app itself on the device need employee attributes?
Well, the source identity provider, like in the enterprise use case, Active Directory is the one that has all of the group information.
Right.
Most of the time, the service provider's data source doesn't have any of that information. They don't know what groups you're a member of.
Well,
so it may not be relevant for, let's say, a Box or Salesforce, but if you're building an internal enterprise application, you might want to be able to provide that other information back to that calling app.
Well, I know the app, the big picture app needs identity information. But if I understood this use case, it's the device, it's the app on the device.
Right.
That needs identity attributes.
Right.
And I don't know what that use case is. Why does the native app need to know my groups and roles?
You could do business logic in the app, even if that's not a very good security model. It could.
Well, that's my question, right? What?
Yeah, we did run across other use cases where one vendor was building a telecom type application that did PBX, virtual PBX type functions. They needed to have additional information out of the directory. And in their case, they needed to be able to query and pick up, the phone numbers for other people in the address book, essentially. And so we wanted to make it a little bit more like both PAM and NSS. On the Unix, Linux, and NSS is the one that's naming service. I can ask about groups. Because again, the application is running inside a trusted space on a corporate-enabled device. And that was just our thinking with respect to how we built that. Right? And those applications have authorization and ability to go query LDAP in read-only mode and gain access to any of the data set that's there. The rest of this should be pretty easy. The identity provider API was designed so that we could plug in other identity providers. Obviously, we built one that ties into our system. There's no reason why we couldn't make one that's a little bit more generic for other SAML identity providers, or enable each of the other identity providers here to be able to create their own. That's relatively simple plugin on the bottom side of it. The other difference is that the identity provider is responsible for the native on-screen login dialog box for initial registration. Because we imagined, just like in the Mac and Windows world, especially with federal government customers, if they really wanted to use smart card on the device, and smart card was a mechanism for registering the device, that you're going to need to modify the login screens, right? If I insert a smart card on a Windows machine, it automatically toggles from user ID password to welcome, David, enter your PIN. And once I enter my PIN, then they can do their PKI function all the way back to their directory to go validate certs and get your initial identity token or biometrics. The enterprise administrator should also get an MDM set of APIs that enables them to manage that identity framework. We needed to be able to control which applications are authorized to make these calls to get single sign-on. If you're installing those into the container, then as the enterprise IT admin, you know which ones they are. You can make that automatic and add them to the whitelist, but you don't want just any application inside the container making a call to ask for a security token. I certainly don't want a bad application or one that is asking for a security token, ask for a security token for Box if it's not the Box client. So we tie those two things together as well. And then we added a few other commands there for the identity service provider, just because if the user were to lose the device, we wanted to be able to disable single sign-on so that it didn't work because I lost it. I believe I know where it is, but I don't need you to do a full wipe yet or a full enroll. I mean, those are a lot of decisions that IT would make based on the particular situation. Or maybe force reauthentication, which puts it back at the initial state where it's like nobody's ever launched and used the application before. Some of these things were possible because we were able to work with Samsung to help manage and make sure that we knew exactly which applications were inside the container. We could be assured that IT was the only one that was able to put apps inside the container, because the first iterations of that, the user couldn't put apps inside. I think ideally this should be something that's standardized and part of the operating system, right? Because the abstraction framework and the ability to manage the identities of the user and hook up to the enterprise identity service is something that belongs to the operating system functions, just like it does on other standard desktop, laptop type platforms with identity providers plugging in across the bottom. But we still run into a few challenges with respect to sharing state across applications or tokens across those apps, especially on iOS. And then being able to make sure that we can securely identify the apps in order to get single sign-on for the correct applications. Because again, it's different on Android than it is on iOS.
Does the app need to know it's running in a container or no?
No, it just needs to be able to make a call to the API. And if it gets a response back that indicates that the user is set up for single sign-on, then it knows that it's in a container and can get single sign-on, or that it's on a device. There's no reason why it has to be in a container, right? You could choose to deploy this to the device and let other applications call into the system. In fact, that's how we do it on iOS. So it doesn't mandate the use of a container, but from a security point of view, the IT guys are more comfortable with a container type approach.
So as a user, if you enter david@centrify.com, it would figure it out that you are enabled for SSO and do the appropriate flow. If you enter david@gmail.com in the same app.
Well, the only login screen that you're ever going to see is at initial registration of the single sign-on service. So the single sign-on service is the one that presents the login screen to the user to ask to authenticate against the enterprise's identity provider. And so the enterprise's identity provider, in my case, would refuse anything except David McNeely at centrify.com.
But I thought that you're going to have to your use case, I think, you're going to have two copies of the Box app. One in the container with enterprise controls and one outside.
Because one of the goals you said is that, you said one thing is box should not have a box for good and box for AirWatch and box for mobile iron. The second thing you said is box should not have a box for enterprise and a box for consumer. But if I hear you right, in this case, there would be two instances of box application on the device.
That's actually only possible if you're using a container that separates those two worlds.
So if I do not have the container and I have a single instance of box on the device, and I click on the app,
if it made a call to the SSO, then it would always operate under the business.
But how would the app know when to call the SSO?
So basically, just briefly understand, I will talk to you more on this underlying mechanism. But the box definitely needs to know that, okay, I'm running on some sort of box device, then call a system API, so you have an SSO API available. So if not, then box, okay, it's not on a web box, on a regular Android device, I'm going to call this.
So the box app needs to know it's running on a Samsung device?
Yes. So of course, we can overload, account managers if box by default use account using our app, but we didn't have that much. We just use new API, the application,
So it's a similar issue for NAPPS, right? That a given app has to know if there's a TA available.
Yeah.
That would be the advantage of that proxy model, right? The app would. And how you discover whether apps are present on the OS is kind of crucial.
So I would have
been that on the device. What we are doing is the app is not associated with individual TA concept on smartphone here, is tightly related with automatically connected concept. But in our test app is just idle the device. So the enterprise can configure on the device on the container side. You can use OpenID, you can use SAML, you can use all different ID and protocols like that.
Can I challenge your question a bit about detecting that a given TA is small device if the Salesforce house user type their email address and they go to their server and say, that company has goddamn told me that my employees will only be authenticated. Today it's via SAML, but the future could be SAML employees only if this app's on the phone. So they don't even have to know that it's there. They just have to know that company has said the only way you, Salesforce, should authenticate my employees on the endpoint.
You have Salesforce faulting back?
No, he's assuming you require a user email address.
See, that's what I thought would be the experience, which is you open up the app, you enter the email address, and then depending upon the email address, Gmail versus Centrify, the Box app backend server knows whether I need to redirect you to the IDP, and hence I assume you're going to have a TA, or I just allow you to enter your password because it's a personal use of the app.
You can't get the zero prompt experience that way, right?
That's not an insignificant burden on Box, right? To know for a given enterprise customer
to do that today,
whether they use an app.
They know whether it's SAML, password, or OpenID Connect.
Yeah, they do that today.
The difference between 3 and 4.
6 and 7, are they just?
They have to know the authentication basically for any given user. I mean, accept this or that.
If you go to Box app today, they first ask you they go to the same flow.
So in a native app, if I go to a browser,
if you go to the native app, they need to know that you're using Box as a personal, or you're using Box in the enterprise setting, which has SAML IDP configured.
Yeah.
Yeah,
right.
and
they
challenge there is
that
the user
off
is
my
given a choice.
email.
Yes.
Well, what is different in this model, if I understood correctly, is
the Samsung not on it?
Well, just in the generic idea of the SaaS or the app facilitating TA discovery. Is that the idea? That the SaaS would say, oh, you're Browning, and I know that Browning is a Centrify customer, so I'm going to tell you to look for Centrify's TA.
Right.
Is that the scenario?
That is a proposal.
Okay.
With an email address, yeah.
Now we can debate how you get the email address in, but that's it. Scout user will do.
Yeah.
That was the last slide I had. I'll hand over to Samsung. They can go a little deeper on how we set some of this up.
Just a little bit deeper on that. So that's a different scenario, right? That has Box knowing that Browning, not that Browning uses NAPPS, but that Browning uses NAPPS with Centrify.
Sure.
It has to know that anyway.
But it shouldn't in a standardized model. It shouldn't care who the IP
Well,
is.
but it's there, but, you know, to be honest, there are a lot of enterprise SaaS vendors who learned that this company happens to use Google Apps as their IDP.
Yeah.
That additional level
Well,
of actually we've already seen.
endpoint.
Well, and that's mostly what it is.
But Browning needs to know the SAML IDP and whether it is Google or King or whoever. And then they can also know what is the URL scheme for the TA equivalent for the IDP.
Yeah, centrified TA optimized for Browning centrified.
Yes.
So Paul, going back a little bit on that, so is it potentially possible to have multiple TAs on the same device?
Sure.
It has to be.
It has to be.
I would think so.
So basically each TA for each service
Not
provider?
just discovery, but you have to have sub.
If each of them are in their own container, then it's actually cleaner. But
Very
it
basic
could
example.
compete.
A lot of people have Facebook and Google installed on Android. Technically, they're two TAs, and NAPPS have to decide which of the two to go to. They get a hand, and they look over time, and they decide which to invoke. They deal with the edge case of the software not being there.
Okay. So following this centralized talk, I think this is a little bit more details on the SSL framework we did on Samsung NOPS platform. So our goal is try to build some kind of generic solution. Generic means, you know, we do see lots of problems and actually lots of pain points that our customers show to us. Many, you know, currently application use individual IDPO, IDM solution, the link the SDK, and talk to service application on device, and then we talk to the backend service, ITP service. You know, Centrify is one solution, and Kerberos is another one, and Samsung's own solution actually. So, we did see lots of problems. For example, applications do develop lots of versions for different ITP solution, or even, you know, actually very frequently applications to be customized or link different SDKs with different MDM MM solutions. Sometimes even different protocol have different SDK. For example, we have experience with Microsoft that deal like this way. So this is actually a disaster for the app developers or SaaS vendors. And yes.
Popped up and said he was the presenter.
I think I had a problem to connect to the network. I tried a lot. Oh, is that?
You should go to the WebEx app.
Let me click the link again because usually, yeah. It's already there?
It's flashing in the bottom.
WebEx app. There you go.
Oh.
There you go. Share.
Oh, share my desk. That's it? Okay. Go back. Can you see now? Great. Okay. So, so these kind of problems we try to solve is, you know, we are in the position of a platform vendor, device vendor. So our objective is to try to provide a general framework for single sign-on or for, say, identity management on Android platform that, you know, we can support easily multiple SSL vendors without, you know, platform change or application change. And the enterprise can customize in a plug-and-play manner. And single version app can support multiple vendors or identity service vendors. So this is a strong requirement. You know, app vendors they are in trouble nowadays. So we try to provide some kind of uniform API for ISV app. So even we look at all the protocols of identity service providers APIs and different SDKs. There are set of APIs very similar. I mean, not exact same, but the application has to change from one SDK to another SDK to satisfy the requirement. The API is not uniform. We try to have some kind of basic one that, you know, satisfy most applications requirement. And flexible configuration with NDM. This is strong requirement for enterprise, as David has mentioned. Enterprise just say, put some configuration, every application automatically run without any user interaction. So this is ideal case. And the IT admin needs strong control. No user involvement. So also we need some capability to write this app So because on the device we're talking about native app share token is very frequent. I think we discussed in the morning all the cases. Fundamental requirement is app share token, but this is strong, security concern. So we need a mechanism for IT admin to say this app set of apps can share on my devices, other apps cannot share. Even they have the capability at the moment, but they should not share. And we have the concept of user scope SSO solution. By user scope, I mean, if you are covered on device, so that device is acquired by the company and then give to employee to daily use, then SSO can be applied on the whole device. So every app on the device can automatically get it. Or in a container case, then the BYOD case, I bring my device and the enterprise, my company create a container on the device. Then this SSO is only for the container or for the application inside the container, not for anything else. So this kind of capability. And we try to. I also had lots of concern on security in this workshop. So we try to enhance the SSO security with platform level security mechanism. So in the platform level, we have like just name an example of mechanisms that are provided by Samsung Locks. We have SE100, a very mandatory access control mechanism for the device, and we have hardware-based token management or key management, certificate management. All different mechanisms can be applied on SSO token management or credential management. And seamlessly, we can make it without application aware, without IDP aware, seamlessly make it work. So the whole mechanism needs some kind of platform level support to achieve this. Some of them we can achieve with application level solution, but fundamentally we call for proposal from Apple, Google, or OEM device OEMs can put some mechanism to have this kind of problem. We highlight architecture here. So so this is the logical view of the device, and then the central part of the device is a system service, which is called generic SSL framework or called CSF. It's a system service. Actually, it's Google Economy is also system service. It's just authenticated this app. This service provides some API, a set of APIs that other parties can plug in to play with it. And fundamentally, they provide APIs for the app. For the app actually is an ISV, SaaS app or enterprise's own app. And they provide APIs for MDM that can manage token, configure the SSO, and set up this policy, this kind of basic configurations. And it also provides some APIs, some basic APIs for the IDP vendor. So IDP vendors say ping or centrify or they can leverage some system provided function to register the SSO service or register the IDP authenticate on the device. So this is this mechanism, just make the application and the management is kind of independent out of the identity provider's solution, so that different IDP solution can plug it in the play without change application code or change NTN code. And so this is the system service kind of glue in the middle. So imagine that is configured SSO and IDP IDM. Authenticator is basically IDP IDM specific APKs is act as adapter to do the protocol specific or service specific operations like get a token, get a user information, revoke token, building trust relationship. This kind of protocol specific operations in device. And so the overall feature is that we try to achieve the ISV app are not SSO service provider aware specifically. So same code can run for multiple vendors. And we have centralized management with this system framework. So system framework we can apply lots of functions in the platform like ISV for Android, trust zone based token management or token storage, and secure boot to make sure the system in the good state, so that the SSO, the whole application and the protocol stack are in a good state. Some these kind of mechanisms. So all the three parties talk to this framework directly. We try to achieve that they don't need any pre-agreement to deploy on a particular device or particular enterprise. So enterprise can plug in and can grab certain applications and and associated with a particular IDP service, then they will work without we developing application, we developing NPM agent, all this kind of thing. So just a few examples. On the left side, application can call get a token, get a user info. The given application can directly process web service request without a get token. Get token is handled by the system for internally. And the system service can connect to multiple authenticators, which is developed by the IDP provider. And we do see that, usually in most cases, and for our customers, one device or one container they use one authenticator. Usually this is the case. There are really rare cases that have multiple authenticators. But no, they can use what the best of the business requirement. They can use which one they want. And MDM agent through IKadmin, they can configure all these kind of links together. So basically, the SSO function on the device is not a building of the application; it's configured. It's this kind of concept. And we do have free license, so everybody can if you go to Knox portal or if you can connect us, we can share some basic SDK, so you can freely to try, freely to develop, and we can check application what is checked, and also the system option we can check signature. That means not only on the package name we can check signature. So in case we know that Google's this open development environment, so sometimes there's some security issue if we only check the package name. If we put a second signature, you can have better security. Yeah. So right now we have this is almost the end, and we have several customers using them quite happy, and we are open to talk with more IDP service or more ISV apps to make it a common. No, this is not exactly on the topic of OpenID, but I think this is some kind of some how to support native SSO on the device. Yeah. Question?
It's maybe dumb one, but do you use the Android account manager behind the scene at all, or is it completely orthogonal?
No, we thought about overload account manager to add this kind of function, but later on I think because in enterprise side, in many enterprise cases they just support all the Google service, so we usually then we develop another one, say it's independent. Yeah.
Right. Then that's also our future or near future effort to cooperate with Google, like Google,
yeah.
And also other OEM. Let's make this one as a really generic solution to support the native apps, and because only OEM can do this work. So regarding the TA, the token agent, so this GSF, this framework, has already embed all the functionalities of TA in that framework. So we can make TA as one authenticator in that framework, or as one module in a system service, either way. And we have reserved one slot for OpenID. Currently, we support SAML, OAuth 2.0, and we are waiting for OpenID.
Well, what I'd suggest is the slot hopefully would be for NAPPS, right? A particular
Exactly.
flavor.
Yeah,
right. Yeah.
Connect.
Our target
Yeah, right.
is exactly native app at this moment.
You're right. So we have some more, all the products, not my OpenID is on our next Mac.
Right, and then if NAPPS works, that NAPPS slot allows you to talk to a Centrify customer or any other IDM vendor customer or a Google enterprise IDP.
Yeah.
Are
Are you planning on doing the same interface, the same NOx limitations for Tizen as well, or just?
Good question. I have now even that's inside something that little bit not very clear on the Tizen's SSO solution. Actually, I think I need to think about that on this. Yeah.
Will there be any iOS solution or something?
Yeah, next step.
Yeah.
Okay, great.
So I think this kind of concludes the presentation section. We're only 45 minutes late, so that's not too bad.
That's good.
For a 3-hour.
3 hour.
So I think, Naveen, you want to go back
Yeah,
and, yeah. So
since everybody has the context, I think it's,
yes.
While we were having a little bit more discussion afterwards, I realized we did end up changing some of the OAuth stuff in these three because of this verifier, which I had written. And this is coming back to the iOS side where you don't know when you return back using the intent, the code, who's going to get it, right? There is no guarantee that this is the app going to get it because many free apps could register the same intent or same custom scheme, and they basically will fetch it. So what we ended up doing was app, before it makes a call, to the scheme to the app, generates a verifier and sends it back as part of the request with the scopes. So we ended up adding the verifier in the call to AS, where you do a bunch of these parts, and when the code comes back, the code, just like request, the standard OAuth 2, is not enough to get you back a refresh token. You have to send the verifier back in the OAuth 2 call to get back a refresh token. So we ended up essentially bolting on some extra stuff on OAuth 2 to make that part a little bit more secure than it was. And we do have a separate spec, as I mentioned, in the ITF working group on OAuth 2, which we call simple proof of possession, which I think a lot of people are debating, but generally agreed on that it is essentially needed to make sure we take care of, no some random app doesn't get the code and get the.
Is that spec the same as NATS?
That's the same, yeah, with NATS, yeah. Right, exactly.
So it's the code challenge, code verifier.
Correct, yes.
It just ties the two requests together to make sure that the original requester is the same one that calls back with the code.
Yes. Yeah, but it does require a lot more changes on the backend side. You have to track it. Yeah, because you have to track the code and the verifier and not, So essentially it ends up being a little bit more changes than what I was saying earlier, that these are all same, but technically that part is different.
And why do you not have that requirement on the Android?
Because you're making a call on the backend API, you're not doing the app flips in this case. So you are returning back as part of the response.
So if the security of the interaction is sufficient, you don't need that extra layer.
Yeah. So if we had some component in the OS where you made a call, then we will be fine. Or if we somehow return back. But the return is coming back completely independently, right? They are two different.
So that suggests the spec would dictate certain security characteristics required of the interaction between the app and the TA, and say, on Android, you can achieve this through these means. On iOS, you might need to rely on additional.
But I think in the spec, even for Android, we are talking about using the...
Yep.
Oh, I should have used the phone.
It's true that there's less risk on Android because the user is prompted for which application to return it to, but users aren't necessarily always the sharpest knives in the drawer. So using the code proof of possession is pretty low overhead in either case and provides a bit of belt and braces in case of user fumble finger.
So I don't...
There's almost no downside to using it.
I don't think we were specifically referring to the custom URL scheme, right? Like that interaction, is that custom URL?
On this one?
No, on the Android?
On the Android is not, yes.
So it's better than custom URL?
Yes.
But that, you're calling an API, but that API, if you were to do intents, it would be the same thing on Google, right? Because multiple applications could register the same intent.
Yes, yeah. So if you were going through the app flip, then yes, you would require that.
And I certainly agree with John. Once the AS has done the hard work of supporting the verifier for iOS, you have to do it there. It's not really much work to ask your Android apps to also do it. It sort of
doesn't work with consistent slap a strike.
Makes it generic.
Yeah, I think we on the mailing list have talked about that maybe OAuth 2 should have actually supported this because it's really a OAuth 2 issue, not really the app specific issue to kind of verify that part.
So this model does presumably dictate that what the TA gives is not an access token. It has to give something to the app that can be exchanged for an access token.
Right.
So is that an architectural decision, John? Maybe we're making that.
I don't know. It's hard. I can't hear the other people, so I'm not entirely certain what I'm agreeing to.
You invited us to Chile for the next face-to-face. So if there's value in the proof of possession mechanism, the implication is that the TA has to give a code or a refresh, not an access.
Well, so there's a couple of things wound up there. So the proof of possession for code draft is certainly required for the NAPPS, the TA interaction with the AS if it's going through a browser. If we wanted to return an access token, then you would actually have to do something slightly different and use the verifier to encrypt the token to the end application, which I don't think is going to be a big seller.
Yeah, we tried.
So if you want to try and leverage this proof of possession, then in principle you could have the application create a challenge and then pass the code back to the end application and have it exchange with the verifier for the actual access token.
I think that's what we're all saying.
Yep.
But I guess my question was, if we like the security characteristics afforded by the proof of possession mechanism, then we have to preclude returning an access token directly to the app.
Returning an unencrypted access token directly to the app would, at least on iOS, given the custom URL stuff, be insecure.
Okay.
It'll be secure until the first person wants to hack it, and then we'll all look like idiots.
Yes.
You wrote the spec. Okay.
Yeah. All right. So you were saying something, Sally. Yeah. Go ahead.
A quick question. You're talking about, okay, so when the app calls up and makes a request, it uses the OS to recognize who it is. At that time, it's going to generate a random number, right? And as that random number is sent up, that random number is now sent to our service to be validated, or it is even kept local. Because the purpose of that random number is actually only to secure from the TA back to the app. It's not really to secure anything else. That's its only purpose, correct?
It's not. It's only validated when it sees it the second time. When the AS sees it the second time, it knows.
No, so yeah, essentially, I think if somebody was in the middle and it can actually intercept the request and the response, then all bets are off. So essentially, we were just trying to secure, and we know that's a possibility, but the request, if somebody else is intercepting the request, then it's not that interesting in that case. Hopefully, by intercepting, so you would not get an access token back. Let's say if somebody intercepted the request, and again, there are some other security characteristics we are assuming that no two apps can request get the particular request which is being from the app. So you're right. And there was a lot of debate in the other part whether to make this a more crypto protocol rather than a very simple verifier. And we ended up not doing because it added up more burden on the iOS developer side. Even
the developers within Google didn't want to add on those bars. They said we don't have the, we want to do all the other burden. So we could do some of those bars, but this was sufficient for us, at least from a mitigation perspective. But definitely.
So in the IDCF draft that we have, which is separate from NAPPS, we had an option of an algorithm transform, which would enable you to do an HMAP, which would protect the verifier going in both directions. But recently, based on feedback, we've decided to drop that because nobody was really all that interested in implementing it. Yeah. And keep the proof of possession for code as simple as possible and add full proof of possession using asymmetric keys as the more secure option to the OAuth proof of possession specs that I'm working on for access tokens. So if you wanted to actually bind the client all the way down to the final access token, you could use the other more sophisticated method. But sort of the middle ground doesn't seem to be particularly interesting to people.
The problem is it appears that you're now moving away from a standard access token that can be used to a standard server. And you're basically kind of saying, it's hard to do it this way, so we're going to do it this way because it's easier for us. But doesn't that mean you have to drag an entire OAuth community of every one of their servers to modify each of those to include those features for that verifier to work?
This change impacts the client, the native app, but not the resource server.
Okay.
This is just a more secure, quote-unquote, way to get the access token.
So you're only using it between the two. You're not expecting the verifier to go back to the
Correct, yes. The verifier is only for this interaction between the token agent and the app itself. Then app would get it. In our case, as we mentioned, you needed to have the refresh token itself, so we didn't add an extra step. You just basically have to pass the verifier back because you were giving back a code in the iOS case, and it didn't make any changes on the Android side. So it wasn't as bad, but I think in the current spec, if you were giving back an access token back, now we have to add an extra step to give you back a code or an access token, which does complicate things further. So you want to continue. So I guess the question is what other things we want to talk about.
Yes, I think
now.
we have half an hour. So topics of what we can do in the next half an hour. We can have more pizza.
You had a list.
Next meeting.
You also had a list of things
we
wanted
had
to
other things
briefly
we could discuss too. I know John was, I think maybe you guys should just have some mailing list. But yeah, I also sent a doc of other stuff if people want to discuss that.
We should just bring up the doc at least was.
Okay.
Are you on WebEx? You could bring it up.
I can be.
I have the doc.
Who was the, I can connect on the WebEx. So one option is we go through the doc that Eric sent out and kind of review some of the points. The other topic is that during the presentation, there were 3-4 items that we thought were gaps. We can talk about that. Any other ideas?
I thought there'd be value in just listing what seemed to be open issues.
Okay. Yeah, because we have, so should we just list out on the whiteboard?
The ones that I'm aware of, and
okay.
then we'll.
So we just,
it is the agenda we have found.
Yeah, we can raise the agenda now. We took care of it.
If you are not presenting, you could just put this.
So I think consent has come up a number of times, and the spec may not even mention it now. And all the different scenarios over who's going to collect consent, where it's collected. Everybody agree that that's a whole?
Yep.
Yeah. Kind of fundamentally, what does TA share? the current spec assumes it's a an access token. We talked about maybe making it a code or a refresh or an ID token. All, I guess, have their pros and cons. We didn't spend too much time on the federation model where we want to support those third-party ASs. We seem to have Emily highlighted two scenarios. Do we support both? Do we pick one?
And how that interplays with consent, because I maybe still don't understand why one facilitates consent while the other doesn't. And they may all actually relate.
But funny enough, I'd say doing the code verifier trick with number 2 addresses a lot of the concerns I had. If I think the enterprise hash providers won't want you messing with their access tokens.
Well, I thought you'd like that because it ensures the apps have the refresh, right?
Right.
Doing away with all of that stuff.
What else?
No, not really. I mean,
Then maybe I don't understand.
Good argument.
So I think there's patterns in Google's explorations. Can we explore how they can be, made generic and appropriate for NAPPS? And any other, anybody else who's explored around this space? I don't know how you describe that. Would Google make a concrete proposal, for instance, on how to?
We need to do a better job of documenting what we already do. How about that?
Well, yeah, this is not public API, that's why.
Correct me if I'm wrong, I think I even said on the bill is we're planning to better document this stuff anyways.
Right.
And in doing so, I think it'll be helpful in a bunch of this group. We all learn some stuff from that, at least we will.
And by the way, I think it's worth mentioning there is still a lot more exploration going on. One of the things I was thinking of is, for example, giving back instead of an access token. If somebody wanted, let's say, Google did a authentication using a SAML with a third party, where Google is the relying party, and could we provide some kind of assertion back so they knew that Google actually did a authentication using, SAML? And so there is a possibility of, instead of giving a Google-based access token or ID token, give something. One possibility is to get an assertion, just push it in the ID token field and give it back. But I think it's worth thinking about where you are doing some kind of a chaining where you give access token, where you say, hey, here is a mechanism where you pass not just your own access token. And this comes back to the other model where, the AS and AS2 were talking with each other. Instead of, it could be, made it more general.
So the ID token has the authentication context parameter, right? Which could be, I guess, extended to indicate where the guy did.
Exactly.
Anything else?
I think the web apps flow.
App-to-app communication? Yeah, I guess that's related to number 4. Web flows?
Yeah, I was going to say the web app flow. Yeah, the one-time token and where.
Yes,
and that's related to consent as well.
So
I do have a mechanism to pop a browser to a relying party for application access using consent.
So we did discuss using that mechanism with the token type none to be able to, if the third party AS populate consent without returning a token, which would then, the consent would then be applied to the assertion flow.
Brian likes it.
Lloyd? So it may be covered under 4, it may be covered under 6, but I'm going to word it a different way, just make sure that we're covering it. We need to very clearly explain what we've been talking about on the trust model between the TA and the application And is it unique for iOS? Is it unique for iOS and Android? In other words, is this a common method, and what is it?
So, yeah.
Cross model between to from the TA and the application. And is it specific to platform?
Yeah, and clearly that's related to this, and hopefully we can learn from those.
Yeah, like I said, I'm not sure that it's different. I'm just trying to define. I'm still fuzzy on what that trust model is.
Right. And what we get for free from the OS and their mechanisms. That list.
I do have one more. We didn't touch on it really today, but a couple of us spoke yesterday, and there seems to be right now an implicit assumption that a native app is associated with an authorization server and a resource server, all of which that can use a single access token type. I think that's a fair assumption in a huge majority of cases right now, but this idea of like a mashup app that might use multiple services and might need different access tokens, I think there's some holes there currently.
It's more than holes, but yes.
So
big holes.
This be part of the discovery problem.
It's
I think discovery is part of it, but not all
It's part of it, yeah.
Right.
Even after he's discovered, right now,
Yeah.
you can an individual app, the way it's kind of set up, can only get really one token for one thing, and there's a potential that it might need to access different resources that need literally different, either tokens issued by different providers or different structured tokens or something like that.
Can't we just wave our hands and say scopes, right? Because
No, absolutely not.
the app is going to say, okay, I know what I'm doing now, I need to call that API. So I'm going to ask the TA for a token and indicate that plan.
No, I mean, hopefully John's hearing a little bit, but this is kind of where the audience parameters come up in context of not the ID token, but the general OAuth request to indicate the target of usage of the access token, and they're doing it for the better than bear, like the proof of possession stuff. But yet the general idea is the same, that a single client might well need to access resources across different systems and resources that have different requirements on the type of access token that they.
But if each of those different systems and resources were uniquely identified by a scope, then how would that not?
That you have scopes like profile insurance.
Very often they're not uniquely.
Well, I know, but that's how scopes are currently built. For Google, you a narrow domain, so you can narrowly name your scopes.
But so just taking that somewhere, what if I wanted to access calendar at Google and at Yahoo? The same app somehow, I don't know. Uber calendar.
I'm not saying scopes are ideal, but you can shove anything you want in there, right?
But if they're using the same value, like there's a lot of cases where it's ambiguous and it can't be used.
But you're saying, is it the same TA? Is it the same TA?
But okay, but so right now there's assumptions that you are routing to a single TA, and we don't have, unless an app then somehow has to represent.
Oh, I agree. I think you would open
apps.
yourself up to an enormous amount of problems.
and which I don't really want, but
that's a related problem, right? If you have multiple TAs trying to support multiple resources.
Single TA, resource limits and different. Anyway, we agree it's a pretty specialized thing.
I think so, yeah, but I don't know if we want to preclude it. It's actually maybe an open question.
You very selective.
So Brian, I think you're arguing for distinguishing between the target and the action you want to perform there. And
somewhat, yeah. Or I think at this point I'm arguing that it needs to be considered at least a little bit more.
The other example could be that you can have like a common Drive app which needs to connect to the Google Drive and OneDrive and something else. And each of those Google Drive and the Microsoft Drive, they have their own AS.
Yeah.
And so in that case, my app essentially on the native app is a mashup of the multiple backend RS, which have their own AS, but I may still have the common primary AS in this model. So when my common drive app needs to reach out to TA, it needs multiple access tokens for different types of RS and AS. Yeah. And I think this is a valid example because people do want to build kind of a common EFSS app which talks to
this is to those mashups, the refresh tokens are stored server side, which are not in the client. So it's either going to be impossible for the local community to do that. Usually the app goes to the server is the refresh server, the server goes to Google. So Google give me an access token, and give me the app gets to call. It's even more complicated.
So, I mean, you could easily solve that when you were specifying scope. You could say, you know, the Google Drive and scope X, this one and that, so you can get multiple tokens back. It doesn't have to be a single Uber token. I don't think single token will work anyway.
I don't think it would either.
So the handshake between the app and the TA is
multiple
just make multiple APIs call.
I think, I mean, that's a fairly easy way to solve
You have
it.
to authenticate into both of those ASs anyway, do the binding.
Were you arguing for a batch call of some sort?
I'm just saying this is the use case that we talked yesterday, which is in the historically on the mailing list we talked about, you know, the first easier case, which is one AS and multiple RS. The second case we talked about one primary AS and then RS to AS combination, but only one RS to AS for one app. In this case, we are saying there could be multiple RS and multiple AS. There you go.
Can we just stay here for a while?
One big dot.
I'm not suggesting
Can you shade that region?
I'm not suggesting we try to solve it today, but note it as an open issue.
So, how, as an app developer, how do I know if I'm trying to make a NAPPS aware authenticating app? How do I know which token agent is installed on the device and to connect to it? Like if I'm going to connect to AirWatch, I'm going to try to send.
So one scenario is that you start off by calling your API.
I'd say, let's learn a lot from what we've done in Sample Open ID Connect. Always make discovery separate. There are multiple ways to do it, but I think we should document best practices, and we should try to include what we've learned from other environments.
Discovery of TA should be a line item. It should be specified. Just in the spec should say this is how the discovery of TA should work.
This is how one way to do discovery.
Yeah.
Fair enough.
Or like say, as Sample and Open ID, you might want to break it out because it's okay to work.
So what you're proposing is there's one way that we put, you must implement this, and we've done that. You
We've
may,
specifically not
on all
done
the
that.
rest, but
in all the other protocols, we've never said you must do it one way because we've learned in all the other cases you can't.
You see, you start there and then you
We said here is one way you could.
And then they all go together, and we end up with 30 different ways that everybody's doing it.
Yep,
It's play well together.
So
in that
a
configuration.
bunch of slides that talk about MDM provisioning, right? That's going to be one way to provision the apps with knowledge of the TAs that they need to know that. The other scenario is to leverage a fault message from the RS, right? You try to use, I guess you make a call and it says, well, first of all, there's no token, so I'm not giving you any data. And secondly, you need to look on your device for an app or a TA with this custom URL scheme or however else you identify it. Good.
But that only works if there's a single TA for RS. If Salesforce is RS, that ain't gonna work.
My thought was that we
Well, you have to discover the.
Then it's a different discovery problem.
Right. We can specify like a default schema that all TAs have to implement, and then they can do whatever they want. You know?
Yeah, then you run into collisions, right? And then you're fighting for that URL.
It could be a hierarchical namespace, right? So it could be like a hierarchical namespace. So, or I mean, in the Android world, it could be like a way the intent is structured, right? So.
Yeah. Well, highlights that it'll be different, likely for the different OSs too.
Right.
Okay. So we talk about the trust model and the mechanisms at the TA on the device. Should we actually talk about how the trust model at the authorization server side? How do you set up the trust with the apps, with the other?
Is that in the specific context of that back channel AS interaction?
Or even for the basic one, just yourself, you have to register, knowing who the apps are, so you know whether you're entitled to issue token to them.
Okay, kind of authorization policies?
Right, kind of,
I don't
for
think
registration.
I don't think the spec is going to say much about this, right? Whether you issue a token to a given app, the spec should support that decision, but it shouldn't dictate how it happens. But what I also heard you say was, token trust models. Are the access tokens going to be jobs? Concretely?
No,
What are they going to be?
they're going to be provider specific.
Okay.
We're not going to change that.
So, and this bullet is talking about those potential choices and the implications and best practices for validation, et cetera.
So one note on the web flows, it's worth mentioning. I personally think it's actually not that different than requesting certain scopes. So some of the Google apps require, they use web flows inside or web views while they get an access token. And all they do is basically ask for a certain scope, and what they get back as a token is usable to go in a browser and bootstrap the whole session, essentially. So all you are getting it back again, an access token or a token, that you can go to a URL. Whether you get the whole URL doesn't really matter. We could return you the whole URL where you, just say, let's say, for example, you say web session I want, and you could get back a URL which you put in the browser, and you have the cookies with the right scopes. So I don't see that much different from the scope perspective where it is in the.
So it sounds like there's maybe 3 use cases for a web flow. One is POP, a distinct external browser. One is kind of a hybrid case, and one is consent.
Consent, I see consent completely different. That's managed by the token agent. I'm talking about if the app needs some kind of a web flow. Right now, they can only call APIs if they have access tokens. But if they want to pop open it, not external browser, but they want to show something in a browser, they could do that right now.
So when I say consent in that context, I mean ST consent, Chuck's use case. I'm Salesforce, and I want my own consent before I issue an access token.
That's slightly different. That could be native consent. The app itself can show a native consent and get back and do this kind of exchange, basically, in this case, and holds onto a token for itself.
I'm not ruling that out. Currently, Chuck's got infrastructure that presumes a web app for grabbing consent.
Right.
And if he wants to tie into that.
You were saying something.
So in your situation, when you propose, how does the session being set to the browser in that case? You have the token.
Yeah, so the Google Apps gets a token and essentially calls the URL and passes the token either through post or get, whatever it wants. And then the Google server starts going to issue cookies, which essentially has a full session.
So it's quite similar to that.
It's exactly. So I'm saying you don't need a special one. It's just essentially, it could be considered a scope, which is say, hey, I want a web session scope with something else.
Pretty similar to SAML blind assertion.
So getting those web tokens is identical to getting an access token.
Pretty much.
Just not used on an API call.
Yes.
We'll be meeting at IIW. Is there value meeting before then? When is IIW?
October 20th.
October.
20, late October.
Late October?
So I guess if tentatively it was mentioned in the mailing list, I guess if we meet end of September, how many days?
We have an hour meeting for the work group on the Monday prior to IIW, and it may be worth dedicating all or part of the Thursday after IIW to having a NAPPS meeting to dig in and make progress on specific work items.
We have an Open ID Foundation meeting on the Monday of IIW, which is slated for the afternoon.
Right.
The morning could be used. We have the room all day. We could use the morning for NAPPS.
Okay.
So both those suggestions are IIW specific. Is there value in meeting before then?
So, John, didn't you say you can be in the Bay Area September 30th or 31st? Maybe you can say that again in the mic so I can hear you.
John, in an email, you wrote September 30th as a possibility.
Yeah. The Thursday after the 2 main days of IIW. We have
maybe he's mixing September and October.
IIW is late October, not late September. We'll
I made up the month.
All right, so he's talking about October. All right, we can get him late October. The rest of us can get him again.
Okay, well, let's keep open the potential of something between now and IIW. But I would suggest, not to restrict who wants to come, but it would be a working meeting more so than an overview meeting. Anything else?
So I guess other than the 11 things, anything else? Or I can take a picture, I'll send it out to the attendee list along with the presentations from all the speakers.
Great, thank you. Thanks to VMware.
Oh. So you wanted to talk more about the
I should take pictures before somebody lights up.
Okay. That's a really old Liberty Alliance. Earlier you said you wanted to talk more about my assertion that for a third-party scenario, the TA would not be involved in Actually, let's provide we will pick a quote-unquote an assertion from the sample from the open ID tonight. But yes, we'll take that as an assertion. But everything we do past that assertion is going to be taken on all sides. In the web index, you have to make certain assertions. You have to make calls. No, should we? Yeah, they're all permitted. Okay. And today, it generally bounces like it's
probably just me and I don't get it.
Yeah, all of those are assertions that come back, but the end result is another